Olympic gold. Nice. Just I just need you to learn how to like break dance now, because that's the new Olympic thing, right? Come on, YouTube. You scare me every time I start you up, but you always work eventually. Come on. There we go. Okay. Oh, for breakdancing? I didn't watch any of that. I just like have heard people like joking about it. Go Canada, I guess.
Hey, Fembox. Yeah, today is a reading group day though. I think I've gotten things started up as much as I need to, so I'll go ahead and hop in voice. So yeah, Fembox and Cook if you're around, or anyone else who's interested in being on voice, let me know. Oh, there's Fembox. I should start looking at problems.
Okay, here I am.
Hey, how's it going?
Hey, good. How are you?
Doing good too. I think Cook said he might join us too today, but I'm not sure exactly when, or if I understood right. So
Yeah, I saw him in Zach's chat earlier, and he did mention, well, he was asking about Purcell, that today was a Purcell day, and I said, as far as I knew.
oh, okay. Oh, you know, I'm gonna forget to say it at the end of the group, so let me just say it now. So ideally next Saturday, it's going to be, hey Dwarfkek, next Saturday will be the first day for chapter 4, but I also have plans with my friends for that day, and I don't know if they're gonna do like, if it's gonna conflict with the time for the reading group, so I might have to cancel it for Saturday, but I'm not sure yet. But
Okay.
ideally we'll start on chapter 4 then.
Yeah, I started looking at it last night. It's a long chapter.
Yeah, I'm like, I don't know if I'm halfway through yet. I think I'm close to halfway through. I did post a link to the Excalibur and like normal like voice chat, text chat, but you know, finding him, let me know. And Dwarfkek, this is a Electricity Medicine reading group that I've been doing on Saturdays. Where we just like get together and talk about some E&M problems. Okay, I'm just gonna pull one in because I've been interested in doing number 21 for a while. These are problems from a textbook. Electricity Medicine by Purcell and Warren. We're currently on chapter 3. Okay, but we have a 4-plate capacitor. 4 parallel plates with large area A, evenly spaced with small separation S. So we have a line tool. Let's do it a bit neater. Oh, why does the line tool... Oh. I don't like that the line isn't even that it makes, but... I guess because they're trying to emulate like how you draw with a marker. Ugh.
Oh, yeah, that's funny. It's not a uniform thickness.
Yeah. Well. And so we have a uniform separation S. And the first and third are connected by a wire. And the second and fourth are connected by a wire. You want to figure out the capacitance. You be on a GIF, Cook? All right, sounds good. So I think there was an example problem that was pretty similar. Okay, yeah, they did one for 2 plates and arbitrary spacing between them. Before I look too deep at it, if the plates are, I guess, like 1, 2, 3, 4, we already know just from the setup that phi1 equals phi3 and phi2 equals phi4.
Does that mean that does that mean that phi1 and plate 1, does that mean plate 1 and plate 3 have like charge Q, and plate 2 and plate 4 have charge negative Q? Is that what we're assuming?
That makes sense to me. I feel like there might be some kind of catch there, but I think that's the most likely explanation, that, or I think it's the most likely thing where they should also have equal charges, I think. Maybe there's some weird thing where the ones in the middle have more charge or something, though. I don't know.
Yeah, I saw you doing a similar problem to this earlier in the week. Well, I don't know how similar it was, but it was parallel plates. And then there was like uneven charges, right? Like one of them had one charge and the other one had a different charge. And you had to find the distribution of, was that the question, of to find the distribution of charges on the 4 surfaces?
Yeah. I remember that. I think it was number 20, the one right before this one.
Oh, okay.
Hey, Kobe Cristiano over on YouTube.
Does it feel like we might have to consider like upper and lower surfaces of each one of these plates?
Oh.
Or is that going too far? I don't know if we need to. I'm just wondering.
Sorry, that might have been a good question. They erased the question. Are you able to like Control Z, or there's an undo button in the lower left? No worries.
Oh, nice. We got some more people here.
Yeah, this is Cook. Okay, cool.
Oh, I should have known it was Dr. Cook when he wrote sup.
Yeah. So I think we have to set up some kind of like system of equations here, I would think. First and third, we want the capacitance. Well, they want the capacitance of the system.
Yeah.
Rather than each individual plate. Yeah, Cook. If you want, you can jump in the voice and just like stay on mute if you want to hear it in real time. That'll be more in sync.
Yeah, what I've been doing is muting the stream, and then so the audio doesn't quite hook up between the stream and the Discord, but it's good enough.
Mm-hmm.
You know, the fact that they told us the area is A and the separation is S feels like those are going to come into the answer, right?
Right.
Because we have a formula for capacitance of parallel plates. Yeah, there it is. E naught A over S.
Yeah. How do they figure that?
Yeah, what was it? Ratio of charge over potential?
Yeah, I'm curious why it should be charge over potential. I'm not sure. I think they define the potential in terms of. Or wait, what the heck? Hmm. So it's kind of interesting. Like if the book kind of sets this up, almost it reminds me of like the electric field due to a plane. It's how they set it for the two capacitor situation. But if we were to like choose a point just like here, we might have to add the contributions from all four of the plates.
I got one of those
No.
little. I got one of those little Wacom tablets.
Oh, nice. I'm just
That's
using
my secret technique for.
notes.
Yeah,
The tablets seem nice though.
they're okay. They're kind of, the one I got is kind of small.
Oh.
I was thinking of getting an iPad. One of the students I've been working with, he just got a new iPad the other day, and it looks really nice. He's doing a lot of homework on it, and yeah, it looks nice.
Oh, cool. I guess I never have given it a fair shot, but I've always preferred like writing things down on paper.
Yeah, me too.
But the tablets do seem a lot more like convenient though.
So if these were just parallel plates, we would have. If these were just, if it was just two parallel plates, you would have C equals A epsilon naught over S, right?
Right.
So what it's kind of like they did was they cut the plates in half and kind of interleaved them between each other.
Oh. Yeah.
I know I've seen a problem like this before. I don't really remember how this works.
Hmm. It is interesting. Yeah, that makes me feel like there's some type of way to like build up from that idea with like cutting a two-plate capacitor situation in half and stacking them. Or
We
is
can
this
do
almost
that
like
kind of.
two capacitors in pair in series? I guess they're not quite in series though. This is Hey, Phobos. Shit, are they in series?
Hey, Phobos.
It's like a fancy version of that other one we did last week with proving some of the capacitors.
No, because the wire's not joining plates 2 and 3. The wire's kind of interleaving them, you know?
I guess so, yeah.
Q1 and Q4. Can we, okay, can we, so we can assume that plates 1 and 3 have the same charge? I wasn't sure about that.
Me neither. I think it'd be the safe assumption to make if I were to guess, but I just like don't know that it's actually true.
I was thinking of doing a little Gauss's law thing again, right? Like, I don't know.
Hmm.
Am I audible?
Oh, hey, yeah.
Hey, Dr. Cook.
Hey, what's up?
Hey, how you doing?
I'm good. So those lines I added, I wasn't trying to say the charge is the same, just that I was just trying to think of the potential a different way.
Oh yeah, sorry, that's your phi, not your Q. I'm sorry.
Yeah.
I gotta get a handle on your handwriting, but yeah, I got you now.
It's that 5-1 is terrible. Yeah.
Okay, yeah, no, that makes sense. So they're at the same potential. That makes sense.
Well, so generally the strategy to find the capacitance of a geometry like this is you put some Q on and then calculate the total potential difference in terms of that Q and take the ratio, or you do the inverse thing. You apply some known potential difference, calculate the charge, and then get the ratio.
Yeah, gotcha.
So there's two strategies here. You could say like apply a delta phi and then calculate Q in terms of that delta phi, or you could apply a Q and then get delta phi in terms of that Q, and then in either case, you compute this ratio, and that's the general strategy for getting capacitance. Just so this is tricky though.
That's one thing I learned from that Halliday Walker Resnick book over the years is that, you know, all these hard problems, they almost always just break down to ratios. You just have to find a way to look at a problem in terms of ratios.
Let me go hunting per cell for a sec.
Yeah, that's like the more I look at it, the more I think like these wires connecting the two plates, it almost makes it just acts like a regular two parallel plate capacitor because you just get past one of them with thanks to this wire. Like I'm trying to imagine the actual like path of the charge. I wonder if that's like a bad thing to do for this, but like if I'm like our positive touch charge to in terms of, for the sake of getting phi, like I could just get right past one of these plates and then end up like down here on plate 3, and then only now do I have the issue of like, you know, getting across from one plate to the other or whatever it would be. Like I almost feel like we're making one of these plates irrelevant with this wire, but I don't know if that's the right way to think about loss.
I gotta see if I can do what you just did. That was cool. Yeah, look at that. You got a little snake that follows you. I like that. Okay, I gotta remember where that is. That's this button here.
It's like off to the side. It's a little weird. I only just now remember that it exists.
So could we just say, I don't know, what do you want to assume? We could assume that plate 1 has charge Q1 on it. Can we say that? Can we assume that the north and south, or the north and south sides of the plate have the same charge?
I don't think so.
So we need 8 phases here, don't we?
I think we should go this route. Apply the known potential difference, delta phi, which in this case would be, phi 1 minus phi 4,
Why
and
do you
then
see
try to
this up here?
calculate.
Sorry.
Oh
go
yeah,
on.
sorry. And then try to calculate the Q between the plates. Although I'm kind of confused with this geometry, like which plates.
Yeah, like when I'm reading it, it's like phi1 minus phi4 should be equal to phi3 minus phi4. And I don't know if that's helpful or useless.
I think kind of useless.
Okay. Yeah.
Yeah. So okay, my idea is to take the delta phis and then calculate the electric field, because electric field so these are parallel plates, so electric field's constant. So this would be delta phi over the distance, right? In general, it's a derivative, but
Oh, right.
in this case. So I think from the known delta phi, we can calculate electric fields everywhere. So I don't want to perturb your drawing. Let's do this here. Can I scroll? Can I not scroll? Oh, 2 fingers. Okay.
Okay.
Right. So let's label these guys. So we're applying phi 1 here. This is also phi 1. And then this is phi 4, and this is phi 4. So the delta phi is specified because we're specifying that. And now we want to see how much charge we get. So the electric field here, that's going to be like delta phi over S. Downward. Let's say this is the higher potential. And then here it'll be delta phi up, right? Because it always points towards the lower potential. And then here it'll be delta phi down again over S. Do we agree?
Let me
This is
just
the
catch up. So
field.
you're saying phi1 is greater.
Yeah, I want to put the
Yeah,
higher potential at the top.
Yeah. Gotcha. Okay. I follow that.
Okay, and then I think from these
You're
electric
saying-
fields. Sorry, go ahead. Sorry.
So I was going to
Oh,
say V is ED. That's another one I remembered. So
That's the same formula
Yeah.
here, yeah.
some of these are
Generally,
they're
we
dirty
have
tricks,
this.
right? But so your electric field is the potential difference divided by S. I think I got you now.
Yeah, in general, it's a derivative, but these are infinite parallel plates. And in that case, we know the electric field's constant, so we can just take the ratio.
Okay.
Okay. Okay, so now we know the electric fields in between in these 3 regions, I think, if I understand this correctly. And then from that, I think we can back out the charge because we know this relation. Where's my? Sorry, I'm really struggling with this.
It's really weird. It's not my favorite.
So using this formula and relating it to what we have in each of these 3 regions, I think we can back out the charge. I mean, my concern at the moment is like, can we assume this charge is the same as this charge? Because that's what happens in the typical parallel plate scenario.
Right.
Or negative, I'm sorry. Negative. Is that true?
Yeah. So charge Q on plates 1 and 3, right? And charge negative Q on plates 2 and 4.
I'm trying to justify it to myself. I think with this Gaussian box, we can say that is true. Maybe. Oh, maybe not. Oof.
There shouldn't be any flux coming out of that box, I think. I mean, I don't think you have to have a parallel plate capacitor with equal charge, but I think you normally do. Which I guess maybe that's the issue.
Yeah, I mean, if the charges are unequal, I think the battery, assuming there's a battery connected to this, which we are assuming because we're applying some potentials, the battery will accept and push charge to make them equal, I think. I feel like I can give a better argument for that. But
We have to assume that the plates are conductors. Is that
Absolutely,
just
yeah.
sort of, yeah, okay.
Yeah, it's why they're being a capacitor.
Yeah, because it wouldn't make sense to connect them with a wire if they weren't conductors, right? That's why they said that.
Well,
Yeah.
you could connect something with resistance to a wire. It's more just the definition of the capacitor, like Don said. If you go to the in section 3 something, he defines it as a group of, like in 3.6. Oh, actually, wait, yeah, okay. Hmm. Let's call this negative q prime and this plus q prime. I think the same Gaussian. Oh, is that true? If I do this Gaussian surface here, do I get a net flux from those fields? I think I might. No, I get zero flux. It's exiting here and entering here. So I think that implies these have to be the same, an opposite, minus q prime plus q prime.
Oh, okay.
Okay, and then we can apply this expression iteratively, like add up the contribution to the 4 fields. So for example, the field here has to be 0. So we can add up, try to work out a scroll here. So let's see, if we're doing, let's call this region 1. If we're looking at region 1, we would say, let's factor out the 1 over 2a epsilon naught. Adding up the electric fields, we have pushing up from the top plate, right? So we got a Q, and we got a track. Yeah, this is identically 0. So I learned nothing from that. Okay. But maybe something less trivial will happen in a different region. So if we call this 2, adding up the electric fields. Let's see. We have the Q from above pushing down. Actually, what do we want to call positive? Do we want to call this positive? Sure, why not? So we have the Q from above pushing down. And we have the minus Q from also pushing down. Wait a minute.
If the charges are unequal, don't we get something really weird happening? Like, I feel like the plates in the middle are gonna have some really weird distribution of charges if they're not equal. Because it would have like, hey Felix, like it would have a different amount of positive charge on one side and negative charge on the other. Like, how do we know? I don't know how that works. If it has like unequal forces on one side versus the other. I guess the other plates might help cancel it. I'm sorry, it seems like you're on a train of thought, so don't let me distract you if you want to continue that, but...
Oh, you're fine. I'm hearing you out. I'm just trying to multitask here. I'm going to drop the 2 epsilons, because why not? My diagram is too small and unclear. If I zoom in, can I do that? Nope.
It's a little like make a box around it and enlarge it. I don't know if it's going to come out looking good, though.
Hmm.
That's the problem that we're working on here, Felix.
Maybe I can just do this in my head. Drop a picture. Right, so if we're looking at region 2, we have that unprimed pushing down, which is positive. We have that primed pushing down again, it's attracting, so that's positive. And then we have the next prime pushing up. Okay, yeah, this seems like it's going to make the electric field 0 everywhere. That's not good. Oh, no. The cues, the outer cues add, don't they? Yes, because the top, in region 2,
Yeah.
the top Q pushes down. And also in region 2, the bottom minus Q sucks down. So this is actually Q over. And we know that's equal to positive delta phi over S. So maybe if we solve, we get something. What's C? C is Q. I always get to look this up. Q over delta epsilon. So let's divide that over. Oh, that should have canceled. Sorry. This might be totally wrong. Wait, I was getting the same answer for a normal. Can that be right?
Oh.
Huh.
I'm not convinced that every assumption I made is true.
I was much more optimistic about having an idea of how to solve this one when I pulled it, but this is trickier than I thought. Felix is saying to think of it as 3 separate capacitors.
I mean, by just dimensional analysis, we know the answer has to be some number times A epsilon naught over D. So the question is just what's that number? There's no other ratio. There's no other ratio of things you can form to have the correct units of capacitance other than this, given the variables in the problem. So the question is just what's that proof factor? This argument would seem to show it's 1, but
well, if we were to go and add in regions 2 or 3 and 4, would we get 3 times that? Was that the goal of this? Like,
no, so given the way it was set up, we said the top plate is phi 1 and the bottom plate was phi 4. And the outer plates have Q and minus Q on them. So by definition, the capacitance would be Q over delta phi. And I found that ratio just by looking at region 2 after some assumptions. That was the structure of my argument. Kind of want to compare against the book answer, but
I mean, it might be right. What you could think of also, so it's kind of like you started with 2 parallel plates, right? And then you cut them both in half right down the middle and take that and sort of interleave it, right? Interleave the, wait, is that right? No, it's more like you folded it. It's kind of like we folded both plates and then interleave that. But then we could reproduce it, right? We could cut this picture we got again in half and kind of fold it again and interleave it. So then we'd have like 8 plates. And so if
yeah,
right. So is there some argument there we can make about sort of iterating the procedure?
My spidey sense says that's not a good approach because when you start moving plates around, you're changing the capacitance because capacitance is a geometrical fact.
I do like the idea of it. I guess my drawing isn't perfect though, so you have to like disconnect them. But
so what about this? So what about this? The top plate, half of the top plate is still distance s from the bottom plate, right? but the other half of the top plate is distance s from the bottom plate twice, right? So that feels like it's going to be a 2 to 3 thing going on. And the same with the bottom plate. Half the bottom plate is still the same distance from the top plate, but the other half is sort of has been, you know, folded back between them. So it's now, right? I feel like there's a 2 to 3 thing going on here. The area is the same, the distance s is the same, but the
Oh, did I take your space, Finvox? Sorry, I see you hovering around.
No, I'm moving.
We agree this is the setup, right? So this potential difference is the same as this potential difference. We agree this is the,
Yeah.
so this potential difference is the same as this potential difference. Yeah, okay, so it's actually like it's like the two plates are in parallel, I think. Well, is that correct to say? I want to check this to see if my earlier result is correct. Where are these at? What number is this? 21.
21, yeah.
I'm trying to see if is there a way I can like check the answer without spoiling myself if it's not right?
I think all you can do is like scroll down, look at the first sentence or something,
Okay,
or something. Or,
yeah,
you know,
I'm wrong. I'm wrong.
Okay.
I'm wrong.
He was saying, think about what happened if there's only charge on the outer plates and you let time run for the capacitance between those plates. I'm imagining them kind of equalizing, but I don't know if that's like my intuition isn't. I don't really trust it here.
But it's 3 area over 2. It's like we took the area and multiplied it by 3 over 2 is what I'm thinking.
How so? I'm not following the argument.
Because like I said, I mean, if we're allowed to kind of think of it this way as taking up 2 parallel plates of area A and then like folding them like I was thinking of. Because
So you're imagining
and it's not
doing
even
this and doing that. Like it was originally this and this. And folded this down
Yes.
and this up.
Let me see. Yeah. So the distance between all the points stays the same, but the area gets multiplied by like a 3 to 2 ratio because half of the plate sees twice as much of the other plate now, right? I remember I've seen those capacitors where you have like 2 sets of parallel plates and you can like turn it, right? It's like an old school capacitor. It's like a circle and you can turn it, you can sort of interleave the plates and make them like overlap more or less. To change the capacitance.
Yeah, I know. Yeah. In fact, that's how like a modern capacitor is made. They roll it up in a big, fruit roll up kind of. That's why there's a lot of
Oh,
those modern capacitors are disc shaped. You can get a lot of
Yeah,
area that way. Not disc shape,
right.
cylinder shape.
Yeah.
so how do we actually get to 3/2 exactly? So the two capacitor or the two plates in the middle are saying they effectively get their area doubled because they have plates above and below them.
Yeah. That's what I want to say. I don't know whether or
Or I
not it's right. I
guess,
don't know.
or that's where the factor of 3 is coming from. Then we're dividing by 2 because we did cut the initial area in half. Is that why we have 3/2 exactly?
Well, I don't know. Trying to use
I
intuition.
believe it. I just like I try to follow it in my own head. Felix is saying we're essentially tripling the area and dividing the distance by 3. I don't see the distance argument. I almost want to remove like one of them in the middle. Like if I move off, like I guess up and to the right, I draw yet another 4 plates here. If I were to remove like this third one and just consider this capacitor here, this should have more capacitance than just a normal 2-plate capacitor because we have more area. Is that what we would expect?
Actually, now that you draw it like that, I don't know, because if wouldn't all the charge on the bottom 2 plates just move up to the top one?
Oh, yeah, you're right. But I guess maybe having then that third plate in there will keep the charges from all flooding just to one end. Hmm. I mean, when I first saw this problem, I was imagining that we would set up a system of equations like the book had with like, oh, what did I just do? It's saying like the charge of plate 1 is equal to capacitance coefficient of 1 times V1 plus C2 V2. Maybe they don't necessarily add, but I was assuming there'd be some type of system equations like this. I noticed that even the right setup for it, though, I'm kind of like blindly applying. Should even? I guess you do. Actually, well, that can't be right. What am I doing? Hey, John Doe, we're on YouTube. I don't like this.
Oh, so is Felix telling us it's just 3 times as big? No division by 2. So maybe, yeah, what we're really doing is we're not cutting the plates in half, are we? We're kind of doubling their size, but then we're taking that new plate and kind of bending it back in between the other two. So maybe it's not a 3-to-2 ratio. Maybe it's just triple.
Hmm.
So wait, is it like 3? Is it kind of like 3 capacitors in parallel? Is that what you said, Dr. Cook? Is this like 3? It's kind of like we took 3 copies and put them in parallel?
Maybe. I'm having a hard time coming up with a good argument for it. And I don't like what I'm seeing in chat, to be honest. I'm not saying it's wrong. I'm just saying it's not argued well.
I honestly, I think I'm at the point where I'm stuck here, and I would want to start like peeking at the answer a sentence at a time, but I know someone isn't ready for that yet.
I dug out my Survey textbook here.
I'm gonna start just like going one sentence at a time with the answer here. Assume total charge on the first and third plate is positive. Okay, so the book answer just instantly claims that the charges do all equal each other.
Spoiler.
Oh,
Yeah, okay. I think that's true. Yeah, from the Gaussian argument. Like if you imagine adding a little bit of thickness, and you do like a box like this that skims into it. I was trying to not assume that, but I think they assert that. Okay, I believe that.
it's like
That's
the first like sentence. Sorry, I think I said you had already like read it, so I didn't think it'd be new for you.
No, I didn't read. I skimmed for some expressions and saw that my
Oh,
first answer was off track.
okay. Felix, that doesn't make sense to me because they're a distance s from each other, and I don't know how considering them very close together is gonna. I feel we can't just make the two middle ones close together and the other one's not.
No, I think the point he's saying is, maybe if I understand it, is that's imagine they have some thickness, and then you'll have charge on both surfaces, equal and opposite. And that's reasonable because the middle plates are connected to nothing. So if they start neutral, they must remain neutral.
Oh, yeah. I mean that could be on board with like Q2 upper, Q2 lower.
Saying. That's kind of what I'm drawing off to the side. I don't know if I'm really making progress.
Oh, I see. So we got 8 surfaces and the top and bottom ones are 0. That makes sense.
Well, there's that problem Don did the other day where if you assume that the charges are unequal, there's inner and outer, right? And then do you remember that problem, Don? Was it
Yeah.
the other day?
Yeah.
And then in the limit that the charges are the same, you see that all the charges are on the inner surface.
Yeah. That's also the reason I wanted to double check they were conductors before, because I know when you have things that are non-conductors, you can get like, I don't know, the answers come out different.
Hmm. Yeah, I'm missing something important here. Okay, I want to peek at the solution too. Uh,
Eh.
oh, he's saying something different.
I'm gonna look more at the solution too.
Hmm.
Hmm. Hey, Nani, over on YouTube. Yeah, it's about capacitors. And hey, Sucked in the Jaw, this is a physics reading group I've been doing on Saturdays for electricity and magnetism. So I'm in a voice call with Fembox and Dr. Cook, and we're working out some E&M problems. But this one is a lot harder than I thought it would be. LCR circuit? Not yet, but I think it's somewhere in the book. Hmm. Oh, wait. This is so weird. This is a 2-star problem? Jeez. Yeah, Felix, I understand that we can give the plates a bit of thickness and, you know, look at the chart above and below them, but I'm seeing out from the answer that's like 5% of the solution right now. It's a lot more involved than I thought there would be. I have a really hard time following this answer, to be honest. I feel like I need to spend a lot of time with this some other time.
When I saw this problem, I didn't think it was going to be that hard.
Me neither. Unless anyone has an objection or something more to say about it, do we just want to move on to a different one?
Oh, I'm pretty stubborn. I don't want to. Well, you guys, I'm gonna go with whatever you guys want to do. But if my vote matters, I vote we push through.
I mean,
I'm looking at
I
the solution and trying to reverse engineer it. So I think we can come up, if we lean on the solution, I think we can come up with something.
okay.
But I mean, it's your stream, Don. Whatever you want to do. I don't want to.
I mean,
Hijack it or anything.
as long as it's not going to take us like another like, well, not another, but like as long as it's not going to take like 2 hours to, or something ridiculous to like figure it out. Let's see if we can. It seems like a neat problem that I'd like to understand, but I don't see myself like quickly understanding it.
I don't understand his argument for the field between the second and third plates.
Do we have to consider the interaction between plates 1 and 4? Or are they like shielded by something in between?
Right now, I'm just trying to understand the fields everywhere, the electric fields, because that will relate to the potential. And he's saying something about that in the second paragraph. So yeah, I agree with what he says about this potential. That's what I've got that part. Since the first and third plates have the same potential,
Yeah.
indeed, the potential difference between the second and third plates must also be. Yeah, okay, I agree with that. Like here, I calculated this is Q1S over A epsilon naught. Yeah, okay. And delta phi is Q1S over A epsilon naught. The 2 disappears because it's additive. Oh, and then if you divide by S, oh, that's the clever part. Okay, now I see. So this points up with the same. I got it. Oh, okay, nice. Okay. So now we've got to get a tricky Gaussian surface going. So I think if we do a Gaussian surface like this is our Gaussian surface S. We will learn that the flux through that 0. Is it 0? No, it's an inward flux. Yeah, good. Okay, so we get negative Q2 is the flux. Which is going to be negative 2 sigma A over epsilon naught times A. Which is equivalent to okay, so the interior plates develop twice the charge.
Oh,
Interesting.
And that's because of the flux basically being doubled because they have fields on either side of them.
Like we have this negative flux coming in.
Bottom plate, yeah.
We have this negative flux coming in, and it's equal to this, right? And it's doubled. But the tricky part, what I think was the tricky part for this was that getting the field here from the fact the field here easily, but these potential differences are the same. So this field must actually be the same magnitude too. That was the trick for me getting that. And then this Gaussian argument gives you this result. And I think we're close. The total charge then we have Where am I going?
Those
here?
inside plates,
Uh,
they see twice the area.
Okay, let me. I want to puzzle over what you just said in a minute. But the total charge we have here is Q1 plus Q2, which is 3Q1. So that implies that the capacitance, which is Q equals CV, so C is Q over V, so we need Q tote over delta phi. Just 3Q1 over delta phi.
I mean, we know delta phi in terms of sigma from the book, right?
Oh,
And
yeah.
sigma can be written in terms of Q?
Yeah, that's a good. Yeah, that was what I was missing. Good.
Oh,
Thanks.
area, right, bring area into it.
Oh my gosh, this is fighting me. Okay, the Q's cancel. And then, yeah, that's it. Is that the answer? Yeah, that's the answer.
It is? Okay.
Okay,
Yeah,
so actually, I see what I was missing before. If you go back to my previous answer here in the green, when I did this,
Mhm.
I was only counting the positive charge on the top plate. I was neglecting that there was also more positive charge on, I think, the third plate. So I was, in calculating the capacitance, I was not taking into account the plus Q2 on plate 3. And that's twice as much charge, so total you get thrice the charge, and that's why it's thrice the capacitance. Okay. Do you want to go over it again? Or
I feel like I have a pretty, I guess like maybe like a high level understanding where we can use Gauss's law to get a switching between Q1 and Q2. And then just kind of matter.
I think the key
Okay.
the key is understanding this field here. Just in the interior plate. That's the, for me, that was like the missing link. Uh-oh. The website just refreshed for me.
Oh,
Yeah, it's starting to do that for me too. I think these whiteboards, when they get too much on them, they start to, at least on my computer, they start to struggle.
we can make a fresh one after this.
I can zoom now, actually. That reloaded. Nice. Okay. Yeah, okay. How about, would it be amenable to everybody if I just redo the whole argument really quickly, as quickly as I
Yeah,
can?
sure.
Okay, I'm going to start adding at the bottom. Okay, this is... Okay, so if we have these 4 plates, that's a, we're going to, so Q equals CV, so C. Q over delta phi. Why is this so large? Okay, so we're going to take the strategy where we first apply a delta phi, calculate the Q that results, the total positive Q that results, and then take the ratio to calculate the capacitance. So let's apply our delta phi, and just to make things simple, let's call the bottom ground at 0. So in that case, delta phi is just phi. We don't. I mean, it doesn't really matter, but we don't want to write delta all the time, so might as well just call it lower potential 0. Okay. And the next step was we're going to get some positive charge on this top plate. And I think more or less the argument is that that's going to do some positive charge on this third plate, because if you consider like this minus Q will induce, sorry, this plus Q will induce some minus charge here. Let's call it Q2. Well, yeah, let's call it Q2. And then this would be positive Q2 by Gaussian pillbox argument. So like using this Gaussian pillbox argument, those charges must be equal and opposite. And using this Gaussian pillbox, these must be equal and opposite. Now, I think that the trick though is that how do you know these are both going to be positive? That's what he asserts in the first sentence of the solution, as Don pointed out. And I think that's...
Well, there's a wire joining them, right? I mean, Because if there's a wire joining them, then, you know, electrons are going to fly from one to the other if they're different signs. They would have to.
These are connected, but how do you know they? That just means they have the same potential. How do you know they have both positive charge on them? Like if this is positive,
Well,
how do you know this is also
They would
positive?
neutralize each other, wouldn't they? If there's any discrepancy like that, and eventually settle into the same sign.
Well, I'm trying to think of it this way: is that if I put a positive Q1 here, that's going to induce a negative charge on this plate, plate 2, just by like electrostatic induction. And then if this is negative, the third plate must be positive. That's how I'm like to think. But maybe you guys.
Okay, it's the same result.
Okay, so we have these charges here. Good. Let me get this nastiness out of the way. Okay, so then what's the next step? Right, so if we just label our potentials, this is potential phi, this is at potential 0 because it's connected to plate 4 at ground. This is phi again, and this is 0. So that means the electric field here points to lower potential, and its magnitude is change in potential of the distance. Same here. And then same here, but this points upward because it's the same potential difference, but opposite polarity. It runs downhill going from plate 3 to 2. Let's give these names so it's clear. Okay, so those are the electric fields. Now we can get a second expression for the electric field. So if we consider the electric field here in this between 1 and 2, the contributions from the interior plates cancel out. They're different. They have this opposite charge, and they're different distances away. But because they're infinite plates, their electric field doesn't depend on distance.
Right.
It's like sigma over epsilon naught. So, or 2 epsilon naught. So in this region here where I put the green X, the only contribution are the top and bottom plates. And each one gives sigma over 2 epsilon naught down. So sigma over 2 epsilon naught down double is just sigma 1 over epsilon naught. The 2 cancels out because you get a doubling effect from the top and bottom both having the same direction. Where's my eraser? Okay, let's get that out of the way. Okay. And so now the same argument says this is sigma 1 over epsilon naught. Okay, now here's the key point for me, which I think is the trickiest part of this problem. These are the same, from the potential picture, these two electric fields are the same magnitude.
Yeah.
But we know them, so this must be also sigma 1 over epsilon naught, but pointing upward. That's the key. By considering potential, we know the magnitudes of electric fields are the same. We already know it in regions like the top region and the bottom third. Okay, so now we know the electric field everywhere, and now we're basically golden, I think, because now we need this Gaussian pillbox here. So that the total charge closed our epsilon naught is negative Q2 over epsilon naught. That's Gauss's law, and then the other side will be the flux. And we get negative flux because it's going in both sides. 2 sigma epsilon naught. I'm kind of confused. Electric field times the area, right? Is that the same area? I guess okay. I can make this. Oh well, actually, here's the way I think about it. I don't encapsulate all that Q2. I get. So maybe calling this Gaussian pillbox having area A is bad because that's this. I don't mean the area of the parallel play. What do we want to call it? Little a.
Small
maybe?
a, yeah.
This area. Okay, so we have in charge.
Why not? Why not just take the whole plate?
We could do that. We could. I think the answer it'll drop out either way. It's the same.
Yeah.
So we'll have this much charge on the left, sigma 2 over A, where A is our Gaussian pillbox area, and then here we'll have little a. If we took the whole thing, that would be big A, but it would still cancel.
Yeah.
So this is equivalent to saying that sigma 2 equals twice sigma 1. That's the statement that the interior plates have twice the charge. So Q2, the areas are the same as 2Q1, which implies that Q total, Q1 plus Q2 is 3Q1. And we also know that the electric field in that top region is sigma 1 over 2 epsilon naught. No, 1 epsilon naught because it adds. Right? So that's Q. Now we're going to use the whole plate area. What am I saying? What am I saying? No. What am I saying? Sorry. This is where I got stuck last time for a second. So that we need the total charge divided by the phi that we applied. So that's 3q1 over phi. But what was the point here? The last step. Like q1
So
over
we
phi. I think
substituted phi, right?
Yeah. How did we do that together? I think from equating these, maybe. We know phi over s is q1 over epsilon naught over a. Yeah, okay, so we get phi is q1 s over epsilon naught a. And so if we substitute that in, the answer follows.
Dang.
I don't know why Felix is saying yes. I don't think he said anything like that. But you can take credit if you want. I mean, like, look at what Felix said and look at the answer. I don't see much overlap, to be honest.
Oh, this thing keeps crashing on me.
I also have a hard time understanding Felix's argument. I personally can't say like one way or the other. But either way, I'd rather have agreement than disagreement.
Sure. Well, I think we understand the point now.
And so let's think back to my idea before, where if we took this thing and we kind of cut it in half and interleaved it again, and then we had 8 plates.
Well,
So could we say
should
the
I
answer
mean,
would be 7?
where are you at? I'm trying to follow where you're at. Are you writing somewhere?
No, I'm just talking.
Okay.
So if we kind of took those 4 and cut them again and interleaved them again, so we had 8 plates, right? 8 interleaved, kind of interlocking plates. Then couldn't we say the same thing, that all the inside pairs would have twice as much charge as the
So it'd be
as
1,
the top
2,
and
and
bottom?
4. So you'd have 1, 2, and 4 of 7 charge. Yeah, that makes sense to me, actually.
Oh, 1, 2, and 4.
Yeah, I don't think they'd
That
all
makes
be
sense.
2, but 4 makes sense.
No. Every time you go interior, I think if the pattern that Finbox is suggesting is correct, I think that's what it would be. Every time you go interior, you double the charge.
Oh,
I think that's what the pattern that's being proposed is. Is it true? Probably. I'm willing to believe.
I think it'd have to, because it'd have like the double thing on either side of it, so it should double again. Like, I imagine it doubles each time, I guess.
Well, yeah. I think it would be double by the same, like the orange Gaussian box we had. I think if we could just repeat that.
Yeah.
All right. Do we want to do another problem?
Yeah.
I'm crossing my fingers here.
The next one I have pulled is just a 1-star problem, so we still can hopefully actually handle this one. Should we get into
Don,
Algebra? Oh, what?
Your camera's out of focus on the stream. I'm noticing.
Oh, thank you for telling me.
Yeah. So if you make the new Excalibur draw, will it just yeet us over, or do we? I need to
You have to click on the new link.
Okay.
I'll go ahead and make one, I guess. So I've been putting the links in the text chat that's attached to this like voice chat, but if that's you have to like right click on the voice chat and hit like open chat to see it. Or if you just want to get it quickly, I can message it.
So I'm on my iPad here. I'm not sure how to right click the.
Oh, I'll just DM you them.
Oh no, I found it.
Oh, okay.
I gave me enough. I got it. All right. Yeah, I think I'm in.
Okay. And then I had this problem, and it relies on a couple extra things. Hey, Argy.
Oh.
I may not actually need all this extra stuff, but I wanted to do 25, but it referred to 2.56, and so for the reason I thought I needed to pull that too.
I wrote a midterm for the advanced E&M students once, and I used that 256 problem on the exam. It was a midterm. That was, but in hindsight, that was way too hard for a midterm. 256.
Okay.
like, yeah, only a few kids got it, and they were all like the Chinese immigrant students.
Oh.
All right. Well, that's not very confidence building or confidence inspiring.
Yeah.
Well, I think if we're doing 325, then I think we can assume the answer, right? Or let me read it actually.
Yeah, I just wanted to do 225, but it said C256, so I found an imaging case.
Oh, I think it's just saying you should make the comparison. We'll use 256, but we can solve the problem without it.
And why did I get the other image? Oh, because 56 refers to 2.30. Okay, I think I did. I maybe got a little bit screenshot happy.
No, that's good actually. It's kind of annoying that Morin does that. Get double reference there. Go down the rabbit hole.
Capacitance of an isolated conducting disk of radius A is 8 epsilon naught A. Oh, hey Joseph, new name.
Bronson, I've never heard of Bronson. Interesting. Oh, this is always too.
The energy stored in the electric field of such a disk. Well, oh, this is the energy stored in a capacitor. We just have an isolated conduct. Oh, wait. Well, that's a capacitance, though.
An isolated conductor is a capacitor relative to infinity.
Oh, okay.
You assume the second conductor is infinitely far away. So there's an example in the book where they do the capacitance of just a spherical shell, and you're imagining the other surface is an infinitely large shell.
Well, I see from a B in the chapter summary that U is Q squared over 2C.
Yeah, Q squared over 2C. I'm looking at that too.
Yeah, I was deriving it again.
Oh, nice, yeah.
Compare this with the energy in the field of a non-conducting disk. Why does he just give us the capacitance there? Is that calculated somewhere else? Feels kind of cheaty that he just gave us 8 epsilon naught.
He may have done that in the chapter.
I don't remember.
Okay, so this is 1 over 16 q squared over epsilon naught a. And here we have So what we're comparing is these guys.
Which ought to be larger. I guess, okay. 2 over 3 pi squared is about 2 over what, 27? Which is...
Yeah. Oh, that's bigger than 2
Okay.
over 32, for
Okay.
sure.
Thank you. I couldn't work out the fractions.
I was taking a second too. What you said was actually really helpful. So we're comparing this to 2 over 3 pi squared. 3 pi squared is that's definitely less than 32, isn't it?
Yeah, I mean, pi equals 3. I'm willing to say that for this problem.
Okay,
3.14 I don't think will be enough to bump you over. I feel like it wouldn't.
Yeah, 3 pi squared is about 29.5. So that's a smaller denominator, so a bigger number. So the non-conducting disk is larger.
Oh, so
And-
256 is was a non-conductor. Okay.
Hey, Pen.
Oh, I think I understand. Let me think before I say it, though.
I have half an idea.
Okay. Yeah, I think I understand. But I don't know if I want to spoil it. Let me check. What number is this? 25.
Yeah. I'm thinking about what Felix said about like how the charge will be distributed, and I feel like for a non-conducting disk, like I remember the charge wants to go out towards the rim where there's lower potential, but maybe we're getting a little bit of extra energy because we're given that it's uniformly spread over the surface. So there's a little bit of stored energy where the charge wants to go out to the rim for the non-conducting case, but it hasn't yet. It's a rationale for why it'd be larger.
What's your argument for why it wants to go out to the rim in the non-conducting case?
The rim has lower potential than the center.
Yeah, okay. Yeah, I think that's equivalent to my argument. My argument was that in the conducting case, the charges will rearrange so the electric field is 0, and the electric field stores energy. So in the non-conducting case, there's an electric field present, and that potential that's a non-zero potential energy you have. Whereas in the conducting cases, the charge will move around, so there's no electric field, and that therefore you're lowering the energy.
Oh, okay.
Inside the disk, you mean? Oh, okay, yeah. Inside the disk, you mean, right?
Yeah. Okay.
Well, it's just an isolated
Now you're
conducting
making-
disk, so no charge is moving, right? Regardless, like there isn't field inside or outside in the conductor.
Hey, pin center. Up.
Oh, hey, Penn. Hey, how you doing?
All right, we got Fembox and Dr. Cook here today.
This is Dr. Cook. Yeah.
Hey, Fembox here. The only non-streamer around.
I'd call myself half a streamer. I'm working on it.
Yeah, there's no like a streamer committee that doesn't like defines it, I guess.
Can I be admitted to the council of streamers?
You have to submit an application.
Oh no.
It's reviewed by a panel.
As far as I'm concerned, you're already on there.
Yeah.
Thanks, man. Oh yeah. So actually, I like Don's arguments. I think they're actually equivalent arguments.
We can see what the argument being made in the book is, but I don't know if Fembox, did you have any other ideas here?
Oh yeah, yeah.
Yeah, I hadn't really understood it that we were comparing the same exact thing, except one was a, metal and one was non-metal or whatever. But now I understand that.
Yeah, and in the non-conducting case, as Don pointed out, we're just told by fiat it is put uniformly, but that's not
Yeah.
what it'll do in the conducting case.
Yeah.
So I guess maybe to rephrase what you said, Don, there's more area at larger radii towards the edge, and so the charge can kind of get more room by moving to larger radii, and so the distribution is non-uniform.
Oh, that's a nice way of thinking about it. It was always weird to me to think that the charge should move to the rim, but I guess that's why.
Well, we have a dA is 2 pi r dr. So if we fix dr, we still get larger a at larger radii because of this 2 pi r scaling. So at larger radii, even for the same dr thickness, we get larger area. Like,
yeah, it's just like it's just weird, bro. Like if you do have, okay, yeah, you're about to like make a drawing like I wanted, but like it is weird to me that the charge would rather let this space here or even like down here be empty.
Yeah,
by that same logic.
not empty.
I guess,
Yeah,
I guess
let me
less.
say-
I
let me
guess.
say that.
Okay. Oh,
Let me say something about that because I've been trying to wonder about it because, let's say I had a solid metal sphere, right? And I put 100,000 extra.
When you say
I put 100.
when you say sphere, do you mean shell or like a ball? Is it filled in?
No,
Or,
solid all the way through a ball. Okay, a ball, yeah.
ball. Okay.
And so let's say I put an extra, 100 million electrons on it. It's I can sort of understand they want to go to the outside if it's small, but what if I take it now and magnify its size by a factor of 100 so it fills the whole room? Now I got all these electrons that all want to live on the outside, really, really close to each other. I don't really understand why none of them want to go and live in the middle where they can get far away from all their.
So Don, what you said was I was incorrect. It goes strictly to the outside, right? That's what a conductor does. It has zero net charge on the inside. So you're right. It would go strictly to the rim, wouldn't it? And nowhere inside.
Wait, shouldn't I think I was misspeaking.
No, I think I was. I think you were correct.
The conductor should be uniform, right?
The two properties of the conductor is that the electric field vanishes inside and the net charge is zero inside. And those are related through Gauss's law. And so, yeah, so to go back to what Finnbach said, Finnbach, you're saying if I have a big metallic ball, even if I make that ball very large, you find it non-intuitive that the charge will nevertheless reside strictly on the outside? Is that the claim?
Yeah, because if I put enough little electrons on it, I can make all these electrons really, really, really close to each other on the surface, right? And it just doesn't seem like they'd want to be that close to each other when they're all so repulsive.
It would cost energy. It would get harder and harder for you to do that. But think about what would happen if the charge went inside of the ball. Then you would have a net electric field inside the ball, and therefore these conducting electrons would have a net force.
That's the argument I've always seen. Yeah, it's all I'm saying. I'm not saying I disagree with it. I'm just saying it seems so counterintuitive.
Well, okay, so but for me, it's less counterintuitive, or said more positively. It's more intuitive if you just keep throwing charge on it, it will strictly be on the surface, but it is going to get harder for you to do that because, as you said, they are crowding each other. And eventually, I guess they would start flying off the surface into the air. Yeah, like, so what would happen is if you just kept like yeeting electrons onto the surface, eventually the potential difference between that metallic ball, the conducting ball, and the surrounding air would get so large you'd have this dielectric breakdown of air.
Yeah.
Air, it has polarizable molecules in it, so it can't support arbitrarily large potential differences. So yeah, eventually, if you just started yeeting too many electrons onto the surface, you would get an arc, a spark to some nearby, like the ground probably. It would spark to the ground.
Yeah. But why don't some of them want to go and live in the center of the solid metallic ball is my question.
In the pin center. Yeah,
The
okay.
pin center, yeah.
I mean, just because you would have,
Eating electrons.
if you had an electron in the center, you could put a Gaussian pillbox around it, and that would imply a non-zero electric field inside the conductor. But that can
Yeah.
never be
Yeah, I hear you.
because the property of being conductor is that it's infinitely easy to move the charges around. So if there's a non-zero electric field inside the conductor, that would be like this non-zero force on something that can move infinitely easy. It would just accelerate infinitely fast back to the surface to cancel out the field. Well, not really infinitely fast, but like in this model that we're talking about.
Where does the idea of where does the idea of eating electrons at a conducting ball, like, where did that come from? Because like
That's from the mind of Finbox.
because like I always thought of the electrons inside the conductor as being innate, and then you have some kind of external field that just rearranges whatever electrons happen to be there. You're not like adding
Well,
electrons to anything unless there's a wire.
Yeah, I think that's what he's imagining. I mean, like for simplicity, we could say you could grab it and put it on there, but in reality, you would have to use a battery or something to push them on.
No, in my mind, I'm just God. I just make those electrons appear on the surface of that sphere.
In that case, if you're just a god, you can do it for free, I guess. You don't have to worry about. I mean, you can just like define the physics. You don't have to, do any calculations.
All right, should we do another one?
Yeah. We usually try to shoot for like the 2-hour mark, so hopefully I can find one possible in 20 minutes. It's easier said than done with Vercel, though. Oh, okay. This one won't have a solution for it, but it is a 1-star, and it looked kind of interesting. Number 31. I'll put it just right below where we were working.
Oh, the same one? Okay, I already left. So we're doing the same.
The same Excalibur, yeah.
Got it.
Since this one hasn't yelled at us yet.
Oh, it looks like a little maze.
Yeah, that's what intrigued me.
Cylindrical-ish. Okay.
Oh, I guess ish because of the little gap.
We're just gonna Gauss it, aren't we?
Hey, call me Am. It's called Excalibur. It's not perfect, but it gets the job done. Try surface charge relies on. There is no electric field in an empty cavity inside. Okay. So I guess the gap might cause an issue, but yeah, but I think it makes sense for like the inner and outer surfaces. I think if that gap didn't exist, this would basically be a point charge with Q. Because you'd have this like alternating. We should have like a minus Q distributed around the inside of the inside surface.
Yeah, I think you're right on. Oh, but actually, so I think to get around the gap, we just choose a different Gaussian surface that skims the. Maybe I'll draw it here. Can I zoom in on this? It's not letting me.
Yeah, I feel like we need a
Oh,
bigger.
nice. Don,
version of this.
yes, excellent. Okay. Are you making a?
I I guess
not
maybe
quite
we need
right.
a
We need-
second like border here, don't we?
Actually, drawing it on the inside might have been easier.
Yeah. Wait. Like
Yeah,
that.
like-
Yeah. Oh wait. Make it thinner. This reminds me of
Is there a
that.
fill tool? Can we
Uh,
just fill that? Like that's the interior.
oh, it would
isn't
be
it?
nice to fill it. I don't see the classic bucket icon.
Mm,
I mean, we could do like a lazy like shading, I guess. Like,
like that.
oh wait,
Oh,
the
okay.
orange.
Either way.
That's the vacuum part, right?
Yeah, I was gonna either way.
Oh, you're gonna. Okay, yeah. Actually, this looks terrible. I think.
I see. Okay, mine's in German, but I see background and filling. But I
Really?
can't use it.
Oh. Yeah. What is that for? Mine says stroke and then background. What is? Oh
And then
wait.
below that.
What? Why isn't that? What does that do? I can't figure out what that does.
So I think this is the first Gaussian circle. Oh, you got to close it up, and then it automatically fills. Oh, that's what happened to me. just now.
Oh.
I didn't want that to happen there. Oh well. So if you redrew that interior or vice versa, that fill? Good, it didn't. So if you take this Gaussian surface that barely skims the inner surface inside, and then that connects to the outer surface on the outside, you get a minus q distributed equally there from Gauss's law.
Um.
Because S1 is totally inside the conductor, so it has no electric flux through it. It's just barely skimming the inside. In the inner cylinder, it's barely skimming the inside of the inner surface, and on the outer cylinder, it's barely skimming the outer surface.
And it encloses no charge, so there's no flux through it.
Oh,
That's what you're
okay,
saying?
yeah, sorry. Yeah, that's not good, sir, because it doesn't enclose the Q. So it has to enclose zero net charge, but that's not the Q. So never mind. Oops. Okay, I'll just leave that alone. I think we just need the correct creative surface.
Yeah, so I guess like what's maybe wrong with what to me seems like the natural like first choice of just doing a circle and forgetting about that gap.
Because then you're not guaranteed it has zero flux. Some flux can pop out of that gap. So
Okay, yeah.
let's write the equation out. You would get the total charge enclosed is Q over epsilon naught, and the total flux would be zero, but except you would get, let's call this E here, EG for the gap times the area of the gap. Are we allowed to assume it's a small gap or no?
Yeah.
Yeah, it should be a small percentage of the overall circle. I feel like that's not crazy.
Does he say that though?
I don't think so, no.
I don't think we can assume it's tiny. So this is actually might not even be true. It might have to be like an angle. So that's my bias against that surface. But there are probably other ones we can think about.
Hmm. Electric field in an empty cavity inside a conducting shell. So, is the condition that we're really trying to enforce here is that there shouldn't be any field only inside this conductor. Like, if we did have flux coming out of that gap, that might not be the end of the world.
No, there will be flux coming out of that gap.
Okay.
That will definitely happen. But I'm just saying the existence of that flux,
It would mess
I
up the
think, makes
thing that
that-
I said.
yeah, it makes that surface maybe less useful, I'm thinking. But yeah, as I don't know who's doing the red right now, but yeah, that's the claims that inside it's like what's this called, a Faraday cage. In the interior, this white region inside, we should get zero electric field.
Okay. I'm an empty cavity inside a conducting shell.
Yeah. Um,
So what about the field lines coming out of that charge Q? Where do they terminate? They're going to be some terminating on the inside of that conductor, and then there'll be some escaping through that little channel.
right.
But can we argue that most of them terminate on the inside of that conductor?
Probably, but I don't think we want to say all, because then this would just become the standard problem that looks like this.
Yeah.
So it's distinct from that. So that gap is important.
Yeah.
I'm just trying to think of a Gaussian surface that would be amenable to analysis.
I mean, could we try and like define the flux that's hitting the actual?
Couldn't we just say like Q minus? We could say there's a negative Q minus a little delta on the inside, and then a Q minus a little delta on the outside? Or delta is
something
like
that? I think.
Yeah, I think you'd want. Yeah.
Oh, go on.
Sorry. Go ahead. I wasn't going to say anything important.
Okay. So everyone else situation where you give Q just a little bit of volume, and then our Gaussian surface is maybe nearly a circle, but with that little cutout.
Oh, geez, that reminds me of what physics and depression was telling us that one night, that you can think of a point charge as a little sphere and kind of cut into it and find an angle in it, right? Is that what you're thinking, Don?
Yeah, basically. Like just cut out the little part of the gap, and then that should be the flux that the conductor cares about, right? Because if the field line never hits the conductor, like that one little field line that's escaping, I assume the conductor just doesn't care. It's not trying to neutralize that.
Well, there's another fact, which I'm not sure I'm following what you guys are saying, but another thing I'm thinking of, maybe relevant, maybe not, is that the electric field lines, they have to be perpendicular to the surface of the conductor. So in the gap, they have to look like this. At least initially, they could come off like this, right? But they have to be perpendicular to the conducting surface. I don't know if that helps.
But the one that's going perfectly straight out, that's just like the conductor. I'm thinking the conductor won't react to it at all.
Yeah, no, there will be. I
Okay.
agree with you. There, like by symmetry, there'll be one that definitely comes straight out. But I'm just saying
Oh,
that
but I
they
guess there will
can't
be
terminate
some.
like
Okay.
they can't terminate at an angle on the conductor. They have to go 90 degrees. Probably that's not useful.
I mean, well, actually, okay, so if all the field lines except for one from this point charge do terminate on the conductor, a single field line is insignificant for an integral, right?
Well, I'm not sure. I'm not sure if that's true either, right? Because the point is that the field lines have to terminate on a charge, a conductor, or infinity. So you could have something that looks like this too. This has to be left-right symmetric. I guess I was saying a very weak statement that when it terminates on the conductor, it has to be at 90
Okay.
degrees.
I guess, yeah, I'm maybe wondering then if I was imagining that anything inside this like little angle that I called theta, I was assuming that it would escape, but I guess I could see it terminating on an inside wall. Maybe it does go in a, you know, the conductor will range itself, so the field line will go at a perpendicular angle. Actually, so maybe we care about, oh God.
Oh, you know, look at part A and look at part B. Part A, the charge is outside the conductor. Part B, the charge is inside the conductor, right? There's no possibility in part B of any field lines getting out to infinity. They all have to hit it. Is that relevant? I mean, is there a reason to think that in part A that every field line kind of curves and gets out that little channel there?
No, I mean, there's going to be one that looks like this for sure. Just by left-right symmetry. This one is going to come down and terminate like that.
Yeah.
So there will, I expect there's going to be negative charge on the inner wall somewhere. But that's a good point you point out. Like you're saying in the B, if I draw a field line from Q, it has to hit the wall somewhere. So that's a good point, observation.
It reminds me of that Jordan curve theorem. You know, you're thinking of like the inside and the outside.
Yeah. Well, so for B, we know the electric field outside has to be 0 from the shielding. Because it's shielded by this, as you pointed out. Hmm. I'm noticing he does say indicate roughly. How rough do you want us to be, Mr. Morin? Dr. Morin?
I say let's just keep it very rough.
Yeah. Well, if we want to be super rough, we could say this is just like the 2-disk problem, right?
Yeah.
Like that's no fun though.
No.
So maybe he does want us to assume the gap is small. Maybe. I don't know. I drew on top of the problem and I can't erase it without getting rid of the problem. It's annoying.
Oh. You can like click on the things. I guess we could move the problem, delete whatever writing you want to write, and then put it back, I guess.
Good. Yeah, let's do that. Thanks. Okay, I think we're good. Oh, I want to get rid of that S1.
Too soon. Sorry.
Okay, nice. Okay.
I'm still stuck on my like just like getting rid of whatever flux is escaping. 'Cause I feel like we could make the angle from like the outside of the gap to the point charge and just cut out that little bit of charge and consider it not to be enclosed. Like
Oh. Okay, actually I like where you're going with that, because then maybe you could say we're only losing phi over 2 pi of the flux.
Yeah.
And that
Or something.
Might,
I didn't quite get to the angle part
that.
yet, but something like that.
Well, I think that maybe if I'm interpret rough in like a self-serving way, I think I could just say the flux that escapes is just roughly the fraction of the angle that the gap takes up, as you said. I like that.
Exactly, yeah, the gap to the top, I think, importantly. So otherwise you might get that
I mean,
side.
it's not exact. That's not exact because as we talked about the walls there, but
Yeah.
I think that's within the bounds of his rough. Right. So we would say then that circle Gaussian surface encloses Q over epsilon naught, and its flux is 0 in the parts of the surface, let's call it S, that are inside the conductor, but we do get some flux. Do we have a radius of the conductor? Let's say it's A. Let's say the inner radius is A. Then I think let's put approx. This would be approximately
Oh, okay.
KQ over A squared times theta over 2 pi times total. I can't write anymore. Did it freeze?
2 pi. Right.
Times the total surface area, which would be 4 pi A squared.
I guess,
wait a
well,
minute.
these are cylindrical-ish.
No.
Maybe we just want to keep it
Yeah,
2D.
Yeah, I agree.
Well,
So 2 pi A. Oh no, we need an area though.
ooh, I guess like 2D flux would be the circumference though. If it's a surface.
Let's take an infinitesimal height h.
Okay.
So we'll have, but then you have an angle when it's going up. So I don't like the 3D aspect of this problem. Or actually, what if we just take our Gaussian surface to be a big cylinder?
I feel like we have a point charge though rather than a line of charge, which
Yeah,
is
but the total flux coming out of the charge is Q over epsilon naught. Like,
yeah.
and I think I think this is the right track. But
I want to use the title of the problem as a hint to solve it, and I want to use the very last sentence of the problem as a hint to solve it.
Oh. In or out?
Wait a second.
I want to say something like this. Like as you got this total flux, Q over epsilon naught, but it has to escape. Say it goes to 0, smaller and smaller gap. So I expect the electric field has to go bigger and bigger by this fraction here. But That doesn't really help, does it? Part of this is just interpreting what he means, right? Describe the charge distribution roughly. It's going to be
I
negative
guess we
somewhere,
don't have to do
positive
it that
somewhere.
quantitatively if we have to do it roughly. Like we could say, I would expect the charge distribution on the like most inside surface to be Q like minus a little bit for whatever's escaping, which I think Fenbox said a long time ago already.
I think you mean minus Q plus a little bit.
Minus Q plus a little bit. Yeah, sure.
Yeah.
That's more accurate, but and then we would have.
But would it be uniform, or would there be like less negative or near the gap? I wouldn't expect uniform unless the gap is really small.
Wait a second. I got an idea. So let's say you take a small enough cylinder that's totally inside the conductor, right? But just a tiny little bit out from that point charge. Well, now by Gauss's law,
You're talking about Gaussian surface?
the Gaussian surface, yeah, that's what I meant.
Okay.
So the flux through that is Q over epsilon naught, right? And,
yeah.
Oh, but wait, we can't argue can we argue by symmetry at that point that it would be coming out equally through all that area? Anyway, here's my idea. It was to take that little cylinder and then slowly expand it until it goes into the middle. And I drew one down the lower left-hand corner. I drew the red one I was thinking about here.
Sure.
So they said there's no electric field in an empty cavity inside a conducting shell. So I want to say that red Gaussian surface there's no flux through any part of it except for the tiny little escape channel, right?
Yeah. Yeah.
And so that has to have doesn't that have to have the same amount of flux Q over epsilon naught as the little one inside?
Oh.
Yeah, it does.
So doesn't that kind of mean?
Go ahead.
It feels like that means all the lines got to like channel themselves and shoot out that
It's
channel.
like a flashlight.
Yeah, I agree with that. Or like not all of them. Like you could have something that goes like that, but certainly enough of them have to give this flux. I agree with that, and that's kind of why I wrote this over here in the top right with this 2 pi over theta. As theta gets smaller, the electric field has to get bigger. To get that. I mean, I don't think that's an exact expression, but that's roughly the idea I had. So yeah, I think we're on the same track here. But how can we use that to get the charge distribution? I mean, I get. Okay,
I want to say that means part A is uncharged. I want to say part A is uncharged and part B has the whole charge Q on it.
You're saying, okay, I'm going to draw something in blue. You're saying there's no field lines doing this?
Wait. The inside surface, there's negative Q on the inside surface.
I don't want to say none. I just want to say
it doesn't enclose just Q, right? It encloses Q and the inside surface, which has some negative charge presumably.
If it's true that all the field
Don, maybe you got something there.
Oh.
Well, yeah, you caught me. Yeah, I think you caught me there.
Because there's a bunch of negatives there.
If what Finvox says is true, if all the field lines go out the gap nowhere else, then I would agree that the conducting ring or whatever is uncharged. But I think there are lines that will be like this. In fact, there must be a line like this by symmetry that goes down.
Yeah.
So I don't think that the ring is uncharged. I would expect there would be some negative on the inside, and then to compensate because it's originally neutral, there must be some positive on the outside. And then one thing you can say is, if we draw this vertical line, there's left-right symmetry. So if we understand one side, we understand the other.
Yeah.
So yeah, the question is really like, how does the negative here distribute, and how does the positive here distribute? And I'm concerned about this gap. Like, is there going to be less negative there, or I don't know.
Felix, I see what you're writing, but I'm not quite sure what to make of it.
if we can't let the gap go to 0, then this would be a trivial problem. But that's when you have a hard problem, the answer isn't just change the problem to an easier one. Yeah, because if we did that, then as I said several times now, that this would just be concentric spherical shells, and that's a very well understood problem. I'm sure he worked out in the book.
What I want to do is label like each of these like inside and outside surfaces and just like deep ships. Welcome in. And just like try and like say like q like at least for the sake of the problem, like q sub 1 is about minus q plus some like dq, and we could even define dq to be like some.
Well, dq is going to be epsilon naught times the flux that's escaping. I think that's where the missing charge. The missing charge corresponds to the escaping flux. So
I want to write like 2 pi
delta
minus theta times q. I don't know if that's right though. I just think of the circumference of a circle. I guess I'm implicitly letting the radius be 1 there, but I just think like the arc length of the circle, I guess.
Wait, did you mean just theta? Because if I put theta equals 0 in the expression, I don't get minus q. I think it should be minus q plus theta q.
Plus theta. I mean,
because
I'm trying to get.
When theta goes to 0, you should recover minus q1 or minus q. So immediately see.
That makes sense, but yeah, you're right. Well, I put it right. Theta q just feels weird to me. Oh, that's the and then we're offsetting by. Okay, yeah, no, I completely agree with you.
Maybe there needs to be an over 2 pi here, actually.
If theta's in radians, that well.
I got that mistake screen too.
Yeah, that's why I didn't use Excel draw for a long time because that seemed annoying, but the alternatives are worse.
I mean, I don't hate that. I don't love it, but it's reasonable, I think.
And then if we did that with that calculation in hand, we could say that like U2 is, well, it's going to be the negative of that. That was my, yeah. That was my idea. That it should like kind of alternate.
I think I would agree if like the 1, 2 was disconnected from the 3, 4, but they're connected.
Oh.
So like, so you're saying some negative charge goes to 1. But that doesn't mean all of it is compensated on 2. Some of it could be compensated on 3 and 4 because it's just one conductor.
They are connected, yeah.
Yeah.
That's annoying. Oh, see you, Felix. Thanks for being here.
Good night, Felix.
Yeah, I've been just kind of neglecting those connectors, I guess, because they seem hard to account for. It is a one-star problem, so and they're saying to do it roughly, so I assume we're not supposed to go that in depth with this, but
I mean,
you're right. It probably is an issue there.
Here's a thought I'm having, which is related to Pinbox's point, which I think we've all kind of said this multiple times, but like the flux escaping this gap has to be large. It's all like Q over epsilon naught, but it's getting squeezed into that smaller and smaller gap. So there has to be a large electric field coming out.
I don't agree with that.
You don't agree with that?
I think, well, if it looks earlier with the flux being equal to Q over epsilon naught, we're not just enclosing the charge Q, we're enclosing Q plus the surface 1, which has a negative charge.
Okay, but oh yeah, fair enough. Right. Yeah, I can't defeat that. That's an excellent point.
Yeah. That's what took the wind out of my sails too. I thought I was onto something, and then Don said that, and I was like, oh, yeah.
Okay, so the electric field is not especially strong shooting out of the gap then. In fact, it could just be, I mean, I find this question frustrating because I'm not even sure what would constitute a valid answer. Like roughly describe the charge distribution. I mean,
So that what makes me more okay with just kind of neglecting those connectors. It does seem non-trivial to, or I don't know if it's like considering something trivial that shouldn't be, but that's where
no,
my mind is
I
going
think
with that.
I think that's too assuming too much because then you're saying the charge can't move from the inner part to the outer part.
Yeah, and I
And I
can see
don't.
there's definitely a potential issue there.
I'm sure there's some like clever answer he's looking for, but
So why would the
like going
charge want to move if 1 and 2 are balancing each other? I guess maybe I'm already assuming that 2 is balancing 1. Maybe it doesn't.
well, so like the vertical walls near the gap, is that part of 2 or 3? It's not clear, right? That's like two
That's
two
true.
and 3
Yeah,
together.
there's some kind of border that I didn't define there.
So are you? So your proposed charge distribution, does it have 0 on that vertical wall? You're putting all the negative q or plus delta whatever on 2, and 0 on the vertical wall.
I guess that's what I am saying. Yeah. And I feel like there's some kind of argument to me that it's like parallel to the radial lines
Oh
from
boys!
Q.
Oh boys! Oh
Mhm.
boys! I have an insight, but shoot the wind out of my sails if this is nonsense. Here's an argument. There's no electric field inside that white region enclosed by the conductor, right? There's no electric field.
Right.
So I think that means there could be no charge on surfaces 2 and 3, because if there were charge, you'd have field lines starting and ending inside.
Well, why
So I
couldn't
think
they be the same charge?
even if they were the same charge, they wouldn't exactly cancel everywhere inside. Like if say 2 and 3 have the same charge, plus Q, as you got very close to 2, you'd have a non-zero electric field inside. Like even if they're the same charge, they won't cancel everywhere, just in the middle ring.
I think
Does
the
that
book
make
makes a
sense?
point that there's, even if the charge on the surface is really weird, you still have 0 field inside. I'm forgetting the argument. They have this like image of a box with a really like, what they describe as really like non-homogeneous field, or very, very like irregular, but there's still 0 field inside the
Well,
box.
so we're looking at
Oh,
figure
wait.
3.8, but
Yeah.
there's no charge on the interior walls, is there? That's just charge on the
Oh,
exterior wall.
yeah. So Dr. Cook, you're saying 2 and 3 have to be Q equals 0.
That's what I'm suggesting, and I think,
It's exactly the same damn thing you were just trying to explain to me before, because the 2, 3 is the inside of that, right? That's the cavity inside that conductor.
well, Don is
Yeah.
bringing up
Okay.
a good point, but I'm not sure if I'm convinced by Don's argument. Like, because look at figure 3.8. I agree, Don, that there will be charge on the exterior surface that's weirdly constructed to make there 0 electric field inside. But if you look through that little hole there, I don't think there's any charge on the interior surface. And for the
Agreed.
reason I
Yeah.
said, if there were
Yeah.
charge on the interior surface, you would have field lines starting and
Okay.
ending inside.
Yeah.
So I think for this little gapped ring, it all has to be on that little interior wall, the vertical walls on the outside, and the.
Yeah.
Huh. I I think you won me over because like with Gauss's law, it just has to be zero for there to be zero charge.
Right. So I think this 2, 3 and this 2, 3-ish region, I think those all have zero charge. So it's all 1 and 4 I'm proposing. And then that 1, 4-ish overlap on the vertical. Yeah, I want to give these more names. Let's call calling that 2.5. And I don't know, inside.
Oh, yeah, the walls, yeah.
Yeah, yeah.
I mean, if 2 and 3 are, well, I guess the exterior of the wall. I almost kind of lump. Well, I guess when I say exterior, which I would think that for one, I would include the inside of the walls or the outside, depending on how you want to view it. I think I would lump those in with 1 because there's still some field lines that are going to end on those walls. But I think on the, I guess
Well,
inside
like
the
1
conductor,
it's
it
1
should
and
still
4,
be
right?
0. I guess, okay, yeah. Like maybe halfway but between the transition from 1 to, well, no. No, I'm saying it's all 1 because the field lines come from Q and end on the wall.
Wait, are you saying there's no, you're proposing that there's no charge on that vertical outside wall?
Sorry, I am saying there is charge. Like I would say that the surface 1 is including all of these vertical walls on the inside as well.
Okay, and you just want to call 4 the
4 is
outside.
only the outside and no vertical walls.
Okay, fair enough.
Although, yeah, that definitely wasn't obvious to me.
We just need something consistent to do.
But I think that makes sense for the calculation as I was thinking of it. And then 2.5, I don't think it matters between, like, it should still be 0 is what I'm claiming at least.
I've never heard of the Babinet principle,
Yeah, look,
so I'm not sure. Nothing.
be interesting.
Okay, so actually, maybe we can get an answer we're happy with then. Maybe it's like minus Q plus delta on the inside, 1, and plus Q minus delta on the outside, 4. And that's kind of neglecting the walls, but that's pretty rough. Where delta is the flux. Yeah, okay, here's what I want to say. If we take the flux through the gap and we multiply it times epsilon naught, that has units of charge. And that flux corresponds to the missing charge. So this is kind of what not for 1 and 2. We called it 4, didn't we? So this is kind of what I'm proposing now. I'm ignoring the vertical walls.
Yeah, with the delta. I like it.
I mean, that's very rough. I don't know if he wants less rough. How rough does Morin like it?
That's a good question.
You'd know that better than we would.
Yeah, I'll send him a text.
I'm personally satisfied with this answer. Like, I think delta is good enough to me. We know that delta should have some dependency on the angle that the gap makes. Babinet principle is an optics thing, but more generally, if you have an E&M problem with electric fields, you can swap the electric fields for magnetic fields.
I have to look that up. I've never heard that. Are we happy with this? Or... We have no way to check this, right?
We don't, but we also only talked about part A. Well, I mean, we talked about part B a little bit.
Oh, well, okay, good point. Well, in that case, there's no escaping flux, right? That's as Finbuck's pointed out.
Right.
So maybe this could be the same as the. Well,
I'm going to feel that
I
the
don't know.
very outer surface has the entire charge Q, but the inner ones are going to have a little bit of a difference. That I have a hard time explaining why, though.
I mean, oh man, it's like a crop circle looking thing.
Yeah.
Yeah.
I'm just gonna shade the inside to help me out.
Yeah, I had to like go through the maze to figure out whether Q was actually able to escape or not.
Oh, put that back.
Because I guess I would look at this like, I think we can agree that the charge Q is enclosed. And I would expect that no matter how weird the inside or how weird the shape of the capacitor is, if you're enclosing that charge Q, you're just going to have the entire Q charge on the outside surface. Which I guess you can make
Yeah, no, that's true. This is the
Okay.
like the Faraday cage argument I was trying to make. It's going to shield it completely because it's enclosed. And so roughly I expect minus Q to develop on the inner surface of this crop circle thing and plus Q on the outside, as you said, Don. But maybe he wants more than that. Like, is it stronger near the bulb and weaker towards those downward curving legs? It's unclear how precise he wants.
And like kind of like the quote unquote outside also goes on the inside part here, which is like, I wouldn't expect there to be charge on that like inside outside part and only for the charge to be on the very outside, but I don't, it's hard to say one way or the other for me.
You know what we could do is we could just solve Laplace's equation with this boundary condition. That's how you would do this for sure. You would just code the surface up. Actually, maybe I might be able to do this in Mathematica. Well, not easily, but give it enough time.
Oh, okay.
Like so you want to solve Laplace's equation, which is sourced by that plus Q. So you have like, actually, can I write this here? So it's a delta function centered at the origin. I'm going to put on the charge, and you could smooth it out to like a quasi delta function if you want. But this is what you're trying to solve, and then you need the boundary conditions to be that crop circle. So that would tell you phi everywhere and the field everywhere. And then if you just looked at where the field lines ended and how densely they ended on you could know the charge. So that's how you do this exactly, or I guess numerically.
Okay. I mean,
And this Laplace equation, you can think of, or I guess this is strictly speaking, Poisson's equation has a source. But you're going to get everywhere where that delta function is non-zero, it's going to become Laplace equation. So you think of this Laplace equation, it's like slapping a rubber sheet, but you tape the endpoints to some fixed value on the surface of the boundary conditions. So like where this orange shading is, you want to imagine like slapping down a rubber sheet where the height of that sheet represents the value of phi. And it has to go to some constant value on the boundary condition edge on the conductor. So you might as well call that phi equals 0. And it has to go very high on that charge. So yeah, you could think about it that way. If I slap down a rubber sheet and I picked it up very tall at Q and I made it be 0 on the inner boundary, that rubber sheet would give you the value of phi. And then the gradient of it, the negative gradient would give you the field. And then from there you could kind of back out the charge. Because you have something like, there's a relation like this. where E perp on the surface is sigma over epsilon naught. Did you see that in the book?
Oh, I was just,
Where that's the normal.
not that exact one, but I was just looking at Poisson's equation where the book derives it, but I don't
I think
remember
they
any
did talk
perpendicular
about
thing.
that. I think that was one of the 5 conditions for a conductor, I think.
So if you have a
think he had a
conducting
list.
surface like this, we know that this has to be perpendicular to the electric field. If there's a parallel component,
Oh, right.
it could move charges infinitely easy along the surface. A conductor can't happen. So we have a perpendicular field, and then you do Gauss's box there. There's no flux on the inner part of the box because inside the conductor. So you get and this is the normal direction. I'm being sloppy here, sorry. So this is what that must be at the surface of the conductor. So if you know the electric field, you can back out the charge density. So this is how I would do it numerically. I would solve this Poisson equation to get phi. Then from phi, I would get the electric field by taking the negative gradient of phi everywhere. And then once I got the electric field, I would invert this formula to find the charge. Wherever the field lines are dense means a higher charge. Where the field lines are rare, it's less charge. And then you could know that's the sign of whether it's going in or out of the surface.
That's how you would
All
do
right,
it
that makes
numerically?
sense.
Or just like that's the. Sorry, I was confused on like what part you were explaining.
Yeah, I'm proposing. If we really wanted to see what exactly is going to happen, we could slap this on a computer, and numerically, solving this Poisson equation, we find phi, the potential, take the negative gradient, find the electric field.
Oh, okay.
Analyze the electric field at the surface of the conductor, and determine the charge density, the surface charge density sigma.
Yeah, I mean,
Your Poisson equation, does it say Laplacian of phi equals q times delta x? Is that what you wrote there?
Yeah, so there's a point charge q which exists only at x equals 0. I'm calling the location of the point charge q the origin.
Yeah, my question was going to be what was the delta x? You said it was
The Dirac delta function.
Oh, I see. So
If
you're
you-
just
if you-
saying like at that point the q exists and everywhere else it's 0. Oh, I got you. Okay.
Yeah, on a computer, I would smooth that out with a quasi delta function. So you could do something. There's like well-known expressions for this. Like one thing you could do is like this box. Let's say it has width epsilon. Then we want the height to be 1 over epsilon.
Yeah.
So how would we write this function? Delta epsilon of x equals 1 over epsilon if we're in that, this is x equals 0, and 0 otherwise. And you could take, to approximate the delta function as closely as you like, take epsilon small as you like. So on the computer, yeah, I would write this quasi delta function maybe for like epsilon is 0.01 or something. Then I would solve this Poisson equation numerically. There's like finite element methods to do that. Then I would get the potential by taking the negative gradient and then using a last formula to get the charge density. That might actually be worthwhile to do on a computer.
I think I understood everything you said conceptually. So, but I really liked what you said about this concept of having like a rubber sheet, right? So you're saying what the rubber sheet, the height of the rubber sheet stands for the potential at that point, and we could have it zero where it touches the conductor, and it goes to infinity where Q is. So couldn't we conceptually try and imagine like what does that rubber sheet look like, and just use that?
That's what I was trying to do, but I maybe you can visualize better than I can. But if you imagine that rubber sheet, I mean, yeah, maybe you can get some insights.
Huh.
Okay. Might call the
thing
reading
looks
group
like
day. We've gone a little bit over time. Oh, what? I mean, I don't want to cut off a conversation though.
No, no, no. I was just going to say the picture for part B looks like some kind of Klingon Death Destroyer or something, or you know what? or you know what? It looks like it also reminded me of a power button, like on and off, some kind of power button.
Oh yeah,
Huh.
it does.
I was thinking of like Mel Gibson Signs type
Yeah,
of
yeah,
stuff.
yeah. That's right. That's right. Crop circle.
Actually, Don, could you send this to me, like DM this to me? I think this would be good to do on Mathematica because like
This
I think
board,
I can
yeah.
actually maybe just the problem statement.
Oh yeah, sure.
This would be worthwhile to try to do in Mathematica.
That'd be cool to see.
There you go.
I've been looking for something to do for a first Mathematica stream, and Jeff has all these like really nasty probability problems that I've been too scared to do. But this looks like something that's way more inside my wheelhouse. So
Okay. I mean, I'll be really interested to see if you do could come up with anything.
yeah. All right. So Don, did you want to switch away from physics?
Yeah, I got the people who are waiting for me to do math, so I think I'll switch
Sure,
back to doing
okay.
a normal stream here.
All right. Well,
But thanks for
this
being
was
here.
Yeah.
fun.
Thanks, Don.
You do this every Saturday?
Yeah, the official like group like this is on Saturdays at the same time.
Got it.
And so
Okay.
next time we'll be doing chapter 4 on currents. But I might need to cancel on Saturday depending on how my friends' plans like shake out. So I'll update in Discord probably the day of or the day before, depending on when they like get finalized.
Nice. Okay.
Yeah.
Sounds good.
All right. I'm gonna hop off.
Yeah.
It was fun.
Thank you both. And
Yeah,
see
yeah.
ya.
Thanks.
Mhm.
All right. See ya.
Bye. Okay. Fenbox doesn't stream, but I should give a little shout out to Dr. Cook, who's on the call there. And so, yeah, so sorry, I got a little bit lost in the conversation to look at chat that much, but yeah, Milk, so the relaxation method thing is how the book calls it, and I did it for a simpler situation that the book gave, which was a nice little exercise. And yeah, hey Brian, better to go in and out. That is Suicune. Okay, I didn't know that there's a global Twitch emote for Suicune, and I didn't know the Laplace equation was relevant to Navi or Stokes. Musical keyboard today. Oh, that's super cool. Okay, let me get some music going. I'll switch my title and category, and then Critical definitely has some linear algebra questions. And I told Critical would be done in like 40 minutes, and then nearly an hour has gone by, so I feel a little bit bad about that.
I need to do a couple like little maintenance things before I can fully switch over to before I can like actually look at it though. Answering math questions. This reading group thing is a ton of fun. I really enjoy doing it. Even though the like that first problem that I chose, it turned out to be a terrible choice. I'm not a terrible choice, but like I was so lost in it. But that second one was a lot of fun. Okay, title and category switched on Twitch and YouTube. Let me get, how the hell do you export an Algebra again? Party, yeah, Fenbox agree. Week's physics studies a current event, yeah. Yeah, critical. I go ahead and ask now. I need another minute before I can look at it though. Sorry that it went longer than I thought. But that's the way it goes. $21, $25, and $31. Bam. Get this image. Also bam. Next week will be the first week for chapter 4. Our next meeting will be on chapter 4. You need to cancel. It's coming Saturday. Okay. So critically, you posted a few questions in the meantime. Do you want to talk about the one that you posted a bunch there? Okay, I assume you want to talk about those first. The wires enforce the electric field to be the same magnitude in every plate gap, right? It's going to be limited if the charge magnitudes double each time you move to an interior pair. Yeah, that one, I at first I was wondering if you could get some really weird sequence of integers from that, and I was almost getting Project Euler vibes, but I don't think it's like that complicated. Like you're not going to get something that's that out there. I don't think. Just doubling each time is pretty sensible to me. Smiling coffee bean who's a shining beacon of happiness. Let's at least do a couple of critical questions before I actually draw that. Critical posted a whole bunch. You said your final was soon for this class, right? Oh. Null spaces. I don't know anything about null spaces. Let's see if we can figure it out. This is getting into part of linear algebra that I just really don't know. Okay, double. Really? It depends how they're connected, I guess. Yeah, maybe that's an important. We didn't really discuss how they're connected. So critical. You're still here, right? If you did have to like get up, I would understand, but. You are here, okay. So we need to change a base from one non-standard base to another non-standard base. My instinct says it's going to be like B inverse times C. Yeah, I'm gonna need help with all these questions, so please. Yeah, if you only have like the two, like, if you're adding more plates in the middle without any other, and if those extra plates you're adding don't have wires, I could see it not increasing. I don't even know. So. Yeah, there's a null space problem like further ahead, but for this problem immediately, right Cook. And so that's the only part of this that I remember. So that's why I'm saying if we want to change from B to C, should we do B inverse times C? Because B inverse changes you to standard coordinates, and then you multiply it by C to change it to C. That's my instinct for 2A here. Or I guess, no, it's C times B in, well, okay, you take your proposed vector, multiply it by B inverse, then multiply it by C inverse. So I'm not, okay, yeah. I was getting the order of it wrong, but. That makes sense to me. Okay, I'm glad it doesn't sound completely crazy. So critical, like I said, this is really getting to the edge of my terrible linear algebra knowledge. But if you have a vector in the standard base, meaning like, or canonical base might be called, or something like, as in like 1, 0 and 0, 1. If you want to convert a vector with those bases into a non-standard base, you just like -1, 5 and -2, 4. What you would do is if you want to convert from this base to this base, or like, from the standard base to whatever base you want, you take this and you make it into a 2x2 matrix. And whatever vector you have in this base, you multiply that in. So let's say we have the vector, I don't know, 3, 4. Whatever you get out will be the equivalent vector to this, but with like these for your base vectors. And so, but if we're given now something in this non-standard base and we want to go to a different like non-standard base, -4, -10. There's a typo. The last B2 is actually C2. Oh, okay, good. I didn't even notice that typo. Okay, CB inverse. Okay, cool. Glad to hear that Penn Center and Cook agree here. So if we want to go from this base to this base, what's going to happen is we'll take, it's B and C, right? Yeah. You're given a vector, I'm going to call it x1. Oh, well, I'm going to call it x and y, I guess. If you have a vector in that base, you want to transform it into standard coordinates by multiplying it by B inverse, because that's how you, I guess, undo that change of base and put it into standard. So I'm just going to put inverse and the original B, and we can figure out what the inverse is later. And so this thing here will be in standard. And so now that you have a vector in standard form, you can now multiply your C in to get your vector in base C. So you have to convert from B to standard and then from standard to C is, I think, how part A works here. And so you can get, we basically want to multiply these two matrices together, and so that we can do both steps at once. Like just do this math first rather than this math, then that math. Where'd you get the 3, 4 from? Oh, sorry, the 3, 4 is just a random example that I made up. I should have called it X and Y. The 3, 4 has no relevance. But yeah, the overall message here is that we want to do C times the inverse of B, and that'll be our change of base matrix that we can do any XY times. So B inverse, the determinant of B is AD minus BC, -4 plus 10, which is 6. 1/6 times, and then you switch these two corners and negate these two corners. I think you can probably leave the 1/6 out front, but I'm just going to bring it in. That's our B inverse, and we want to left multiply the C in now. And CB inverse is what we're really interested in. It'll be our answer. So this matrix C is these two vectors made into a matrix. This is annoying, but it's possible. If we stuck with the 1/6, could we put the 1/6 all the way out front? Is that allowed with matrices? I feel like it is, but I don't know that. Oh, you only recently memorized the inverse of a 2x2? Did you just use a program before? I'm just gonna do the hard fraction math, I guess. We have 2/3 plus 20/6. 20/6 is the same as 10/3. So we have 2/3 plus 10/3 is 12/3 is 4. 1/3 plus 2/3 is 1. 2 plus 50/6. I'd rather have it as 6/3 plus 25/3, which is 31/6. Is that right? 6/3 plus 25/3, yeah. And then we have 3/3 plus 5/3, which is 8/3. I think I got the denominator wrong right there, didn't I? Let's verify this in Wolfram, but I think that's the answer. You avoid inverting matrices whenever possible. Oh, interesting. Yeah, for a 3x3, I don't think there's that clean type of formula like there is for a 2x2 that I know of. I've seen, like, I think Benson taught me, like, it's called like the basket weave method or something like that. That might be for a determinant. I don't know. Oh, wait. Bluebird, doesn't B take BI to standard basis? Hey, Cloud. I thought it was the reverse direction, Bluebird. What's the problem, Cloud? I did see the problem you sent to Zach about mapping things onto an egg. I don't know that I have much to say about that one, if that's your question. Or I don't know how to do that one, I guess. View convert. Okay, so oh, you already saw the one? Okay. I'm glad, because I didn't know what to do with that. What was I? Oh yeah, I was gonna check this matrix multiplication. I probably shouldn't just let you do the matrix multiplication correctly. It's probably not the most, you probably know how to do that part, but the point is that whatever the result of that multiplication is the answer for part A. Okay, I got it right. So yeah, for part A, it's that matrix in the lower right. I'd say the answer is. Cloud, I'm gonna work through part B of Critical's first problem here, and then I'll look at your question. Well, here, let me quick look at yours to make sure that I can even start to think about it. Yeah, it looks like geometry. I don't know what you're trying to do with that triangle. Oh wait, I'm sorry, that's from months ago. I was looking at the wrong DM. I'm doing good, Brian. Thanks for asking. How are you? Oh yeah, you want some geodesic curves? I'm not sure that I know anything about that. Yeah, so I'm gonna keep on with Critical's question. I don't know. Oops. About your problem there, Cloud. So for part B, God. Just multiply both sides of the equation by 0. You have an equation solid for all x values. Musical keyboard. Oh yeah, nice. Well, I feel like. Oh wait. Oh, okay. Well, wait. I need to draw this out a little bit. I think I see where that's coming from, Pen. So, Addy Pie, thank you for the follow. Coordinates are a pain, yeah. Oh, yeah, probably is a B2. Two bases for vector space. Okay, so these are two different bases for the same space. And B1 is defined such that it's C1 minus 6C2. And B2 gets sent to, or B2 is just the same as 4C1 minus 3C2. I failed at that, didn't I? 4C1 minus 3C2. So we could write that in matrix form. Like so? Right, change of coordinates matrix from B to C. Is this just it? Yeah, I feel like this is just the answer. Because we're kind of provided the conversion already. So, Critical, I think the key here is just seeing that you have a system of equations and that you can write that in equivalent matrix form. Wait, they're saying from... Oh, wait. This changes C to B. Yeah, we want B to C, so we do need to do a little inversion. Yeah, the problem's asking for B to C. Okay. So, Critical, we interpret this by, it takes a vector in terms of C, and it converts it to B. But there's a little bit of a trick in the question where they're asking you to convert from B to C. So what we do is we left multiply each side by the inverse of this. And that'll isolate the C vector. So I'm going to come over here, say 1, 6, minus 6, 4, minus 3, inverse B1, B2 is equal to C1, C2. And now we need to get that inverse, and then we're done. Tricky. So the determinant is -3 plus 24, which is 21. Swap those corners, negate the other corners. And then, I mean, this is a valid answer too, but we could multiply the 1 over 21 in, just for fun. So I would say the final answer that I would turn in here is that matrix. We've shown that it converts a vector B into C. So Critical, are with me for number 2 here? Christ, you cooked the shit out of it. Maybe I shouldn't block off the problem. Okay. I don't enjoy doing this. Linear algebra is probably the top thing that I need to study. I feel like if I'm being like responsible. I mean, I think the algebra is like equally as important, but if I wasn't having so much fun with the reading group for physics, I think I'd be doing it for linear algebra. So it seems pretty important to know. Oh, sorry. Oh, true. With the Mobius transforms. Uh, yeah. So you posted what, 3 others here? Um, it's just like is this your homework or like what is this? Because it's just like it's a lot of questions, I guess. Like this is a previous exam? Oh, okay. Um, BB the basis of P3. God, I don't know what a Hermite polynomial is. I feel like I learned about like Hermite's like equation. Like, isn't that like a differential equation that Hermite has? Maybe it's like the Hermitian as like a matrix thing. I don't remember. Either way, it's irrelevant to this. Yeah, I'm deferring to chat on this one. So it's like Fenbox has one solution, but Cook is saying there's an easier way. Yeah, I can see how like the choice for D is forced because there's only one term with P cubed. And that might cascade down to the other things. Yeah, I don't know that. Maybe it's easier if you know that. I'm gonna assume that critical doesn't know that though. I definitely don't know it. You think you did as Fenbox? Or what Dr. Cook said? Okay, I assume you mean as Fenbox then, yeah. So did you get it wrong then, or like what was there an issue with this question? I mean, oh, Do A times 1 plus B times 2D. Minus 12t plus 8t cubed. Okay, so I think the idea to solve this relatively quickly is that you notice that there's only one t cubed in the left side, and that no matter what, this d has to get this 8 to become 12, because there's no other way that we'll get that 12t cubed. So off the bat, we know that 8 times d is equal to 12. So d is just 3 over 2, if I can do math. Can we do a similar thing? Yeah, we can do the same thing with the squares. We know that minus 4c is equal to minus 8. So c equals 2. And now we're ready to work on the t terms. If I label what's happening. So we have a 2b from there, or not to be. We have a minus 2 from there. And we know what c is, which is 2. Then we have a minus 12. Times d, which we know is 3 over 2, is equal to minus 12. Now just solve this for b. Minus 22, negative 4, minus 18. Think and hope. Is 10, so b is 5. And now we just need to do the constant terms, which I don't have a very good label for. I'm going to call the constant term c. We have an a, no constant term, no constant term. Oh, really? I made a typo. Fuck. There's no t there. I messed up my last calculation. Minus 18. Ash. 6 and 3, right? I copied it down wrong. Yeah. We saw it at the same time, Brian. Okay. I think that's not that bad of a mistake to make. So constant term. We already know what c is. C is 2. It's equal to the constant term of negative 7. That's negative 4. Add it over here, you get negative 3. So I guess those are your answers. No clue what this means, but the coordinate vector of p relative, well, is the coordinate vector those a, b, c, d in a vector? I don't think I formatted the final answer right. But I don't know what it's supposed to look like. Um, oh yeah, thanks, Brian. It's just a lo-fi playlist. So I happened to see first when I was looking for music to play, to be honest. So critical. I don't think I formatted the final answer right, but I think that's the hard part done. I don't know what it's supposed to look like, so I don't know what to do for the rest of the problem. I mean, I'm a little bit. They said find the coordinate vector of p relative to b. I assume it's as simple as like making a vector out of the answers. So I'm just going to caution you there, but like I wouldn't say just my answer because they asked for a vector of some kind and I didn't say a vector of some kind. So that's my word of warning there. Really? I mean, that's probably true, Dr. Cook, but I don't think it's a good idea to give someone the extremely complicated solution they never learned when they're asking for help with their class. Yeah, I don't like doubting Lubert either. Um, like right now, I just want the simple explanation, but okay. No, okay. Okay, this is anything for R3. That should be good enough for... For what? Make what into vector form critical? Number 4? That's what I'm saying. I don't know the answer to that. I don't know what the final answer is supposed to look like. I assume it's supposed to be a vector like that, but I've literally never done a problem like that in my life. I don't know anything about what it actually means. I was following off what chat was saying. Okay, thank you, Pen. So yeah, I just take the answers for A, B, C, and D that I got and make them. I think it's a column. It shouldn't really matter. Or my instinct is say to put as a column, but that's because I normally see vectors as columns, I guess. Okay. From A to B. Oh. I think this agrees with Lubert. From A. What? The matrix that converts A to E is that original column matrix. I thought it was the other direction. Huh. Yeah, it's on the matrix that I got. At least in the Stack Exchange thread, they're saying M sub U comma V is from U to V. So I think we're okay on that aspect. So if you want to go from A to E, that's when you do the original, like you don't do the inverse. You just take the vectors for what they are. That's backwards from how I remember it, but it's been that long since I've studied linear algebra, I guess. I just want to see like a second source so I confirm that. Because this is really weird to me that it's reversed from what I thought. Critical looks like I think Lubert pointed out that I made a mistake on problem 2. And I'm trying to figure out if that's, or I'm trying to make sure that I'm trying to figure out exactly why I got it wrong, but what is this? Vector 1, 5, minus 1, 5. That, I think that's supposed to be the answer critical. It's not the answer that I got. Okay, minus 1, 5, and the basis B is 1, 0. That's what I'm trying to figure out critical. I don't know. That's the other possible answer, though. 15, 18, 4, 5. I mean, we're talking about for part A, Cook, I think, if that's what you're... I mean, maybe it affects both. No. For part B, I'm pretty confident, but I think we're talking about part A here. Oh, okay. Thank you, Pen. That's like that's the type of check that I was trying to figure out. I just don't even have the common sense to know that with linear algebra that's a good thing to try. So if we take this base vector for B, we expect to get a base vector for C, one of them. So let's try taking this thing and multiplying it by -1, 5. We do. What? Sorry, I misunderstood what you said then, Cook. I'm stupid and I need to be told exactly what to do or else I don't understand it. That makes you feel any better. 4, 1, 31/3. (8/3). -1, 5. So, wait, what? Oh, wait. Why is it? How is this different? Hey, Zach. It's exploding around me. Oh, it's 31/3. Okay, there. Okay, so we were talking about 2A. I thought I had done it correctly, and then Luber pointed out that I might have gotten my reasoning backwards. But I think we're back around to saying that my original answer was right. Let me try this. It's going for converting from this arbitrary, or from one like non-standard base B to another non-standard base C. And so I said the answer is C times B inverse. And I got this matrix out, and I said that was the answer. But apparently there's a chance that I had it backwards and that it's supposed to be like B inverse times C or something like that. Let me try the proposed alternative solution, just make sure. 15, 18, 4, 5. 15, 18, 4, 5. -1, 5. Okay, that's something garbage. Now, if I gave it a vector C, 1, 3. Excuse me, Wolfram. Wolfram, I gave you an order. Okay. We got 69, that's funny. But it's not even from C to B. Wait, 69, 420? I got 69, I didn't get 420. Be hilarious. Dude, oh, that... I want to problem that. Okay, yeah. If only. We need to make that problem. So yeah, Bluebird, I don't know what to say about when you plug in -1, 5 though, that is the vector -1b1 plus 5b2. Isn't -1, 5 in standard coordinates? Is that the confusion? How can you be given a base vector with the vectors in that base? That doesn't make any sense to me. Unless I'm misunderstanding what you're saying, which is entirely possible. Um, yeah, I don't know. Oh, that's what you're saying. Well, huh. Hey, symbolic logic. How's it going? I don't know what to do with this problem. I feel like there's good points being raised on both sides. Ugh. I don't want to look at that. Uh, working on some linear algebra problems for critical thinking in chat. My linear algebra is incredibly weak though, and I thought I had solved 2A here. It is being pointed out that I might not have done it correctly. And so critical did get the same answer as Lubert gets, it sounds, which is making me think that I don't understand what's happening. And so Lubert is saying that when we did this check here, this check here, -1,5 isn't the standard base. It's not in base B. And I don't know how to resolve that issue, or if it is an issue. Trying to write a program to calculate the slope between 2 points. Oh no, Zach. What's wrong with like y1 minus y2 over x1 minus x2? I'm just concerned that critical got the same answer as Lubert, which makes you think there's something that I don't get here. But if critical is saying move on, I'll move on. I don't know what to think about number 2. But you know, you got there in the end though, Zach. That's the important part. It sounds like you did. Maybe you gave up on it, but. Okay. I'm glad that it's like... Yeah, it's not so simple, right, Pen? We need B to E, then E to C. And so that's what I thought I was doing. I thought B inverse is B to E, but I'm hearing that maybe it's not. B is B to E, not B inverse. Okay. So critical, it sounds like the answer that you got is correct. And what I said earlier is incorrect. It sounds like no. Actually, I always forget to give out saves, but thank you for speaking up on that, Lubert. Yeah, the odds just shifted $10. So you remember the order stuff is annoying. Determine if W is in col A. Is that the column space of A? And does that mean we can just like make this a normal system of equations that I'm used to? Turn this into the writing calculus exam. Oh. Dude, like a 6-week course is like crazy short, Pen. I don't know how like, and you're doing two of them, right? Like for complex variables and calculus. I imagine that's not easy to manage. Okay, so what the hell is col A? What I assume we do is we take each of these columns as like a vector, and we do a linear combination of them instead of equal to 2, 1. It is a column space? All right. Okay, I can remember that now, Lubert. I guess I had it reversed in my head. I thought that B changes E to B, but I guess I didn't have it the right way around. So it's been a long time since I've taken linear algebra. AX equals W. Okay, right. So I think this question, and it sounds like symbolic logic agrees, is that it's basically asking you to solve, well, we can just write it symbolically first. AX equals W. And if we plug in for A and W, and I guess we plug in for X, minus 6, 12, minus 3, 6. X1, X2 is equal to W, 2, 1. And you can solve that by like left multiplying by the inverse, where you can make an augmented matrix and do row operations. You retook linear algebra at the graduate level last year. Oh, nice. It's appreciated symbolic logic. My linear algebra sucks. Hey, Agony over on YouTube. What motivates you to do such long live? Thought I have fun with it, to be honest. Minus 6, 12, minus 3, 6. These are dependent. Wait, well, the columns are dependent too. But this might actually, this is probably still in the column space though, because it's the same ratio. So I'm just seeing intuitively that this row is 2 times the second row, but the same thing is true for the resulting vector. This is twice of that. So I'm going to guess the answer here is yes. And actually, we can show it in short order here. We can send row 2 to row 2 minus a half row 1. And so we get -3 plus 3 is 0. 6 minus 6 is 0. 1 minus 2 is 0. Is that a good thing or a bad thing? That's probably a good thing, right? If we multiply that by -1, 6, I don't know if this is even necessary. 1, 2, -2, minus a third. So what does this mean? It means that x1 minus 2x2 is equal to minus a third. I feel like that means that the answer to the first part is yes. Because, yeah, we're able to get an answer for this. If W wasn't in the column space, I think you would get like a 1 equals 0 situation. Okay, yeah, I noticed that like that everything is like multiplied by 2 like at first, but I want to actually like show it too. Yeah, and I'm trying to geometrically interpret that infinite solutions bit. Like, why are there infinitely many ways to get to W with only a single vector? Well, I mean, I guess it's, you have 2 copies of the same thing. I guess that's why. It's not just 1 vector, you do have 2 vectors, even if they're not all that different. Okay. Regardless, it is possible to get to the W vector using the columns given, which, so the answer to the first question is yes. The second question, I have no clue. In the null space, see if, oh, if the given vector gets transformed to 0? Okay. That's not so hard to calculate. W is 2, 1. All right, just have a normal multiplication problem on our hands. We're going to get a 2 by 1 vector. -12 plus 12. Oh, okay. 0. -6 plus 6 is 0. So it is true. So I think we say yes to being in the null space. That does seem weird to me, Dr. Cook, from the tiny bit of information I know about the null space. Okay, I mean, this makes it pretty direct, though. We checked AX equals 0 and it was true, so. Yeah, Pen, that's what we did initially, but then. What? Oh, on the left side of the board there, we do get 0, 0. It's really being a subset of the domain. I think we did it right. I don't know how to interpret it, but the answer is yes. I'm pretty sure the answer is yes, and that's the important part. Okay, so this is the last problem that Critical posted. Oh. Coordinate vector x in base b. Hey, Renga. There were typos on a different. I mean, this B2 is almost certainly wrong. Yeah. That's a good question, symbolic logic. For linear algebra, I don't really know, aside from like trying to like a PDF of a textbook or something. I've heard I think Zach has recommended 3 Blue 1 Brown has like a pretty good linear algebra like website. Or 3 Blue 1 Brown has a good like website and has a linear algebra section on it that might have some problems. I don't know one offhand though. I don't know what this is asking either. Dunlop says AX equals B and AB equals 0? Is this basis supposed to be B1, B2, B3? Your professor wrote this? There's so many typos in this. Like, this is an exam you have to take? Oh, for the last problem? Okay. Hey, syntax. Critical posted a bunch of questions, but if you have a question, I'm going to switch over and work on yours. to spread things out a little bit. So if you have a question, I'll go ahead and answer it. But we can keep on working this until we actually see Syntax's question. Because I don't know. Oh, she's going through a lot. Okay, maybe I won't be that. Or I'll shut my mouth then about the typos. We need to figure out what the question is asking, though. Coordinate vector xb. I can successfully calculate the perpendicular slopes to a pair of points successfully by code. Nice, that's huge. So okay, I see that syntax error. I'll try to wrap up this question with critical, and then if I can figure out what we're supposed to do in a minute or two. If not, I'll just go straight to yours. But since we're already talking about number 10 here, I want to see if we can keep the train of thought going. Interpret the third vector. Oh, this second b2 is supposed to be x. Okay, I was looking at this as the second b2 because there's a b2 right there. But no, that will make more sense if that b2 was the x. Okay. And Fembox found what linear combination gets you there. Kobe, it's basically 5 in the evening for me. If you think I should be asleep right now, then I don't know. You're worse than my parents. It sounds like they're asking you to solve this is messy. How did Penbox note it? They want you to do a linear combination of b1 and b2 and set it equal to x. And this third vector over here is probably x. So let's just say some constant c1 times the vector that we're given b1 plus another constant c2 times the other vector we're given b2 is equal to the x vector. b1 is 2, 3, minus 3. b2 is 1 minus 5 minus 1. x we're assuming is -8, 111. So Fenbox managed to do this by inspection. Was it -3 and -2? Interesting. Wait, that can't be right. That gets the wrong. That doesn't get you to -8. No, it does. Never mind. Is there a more systematic way of doing this? I guess you'd get a. Oh, that's why I'm getting confused. You have 3 equations and 2 variables. That's why the matrix interpretation wasn't like working in my head. So you want to solve this for C1 and C2. You can take any like set of 2 of these you want and just figure it out from there. I'm gonna choose the first and the last one just because I see an easy step that we can do, which is 2c1 plus c2 equals -8, -3c1 minus c2 equals 11. Add the 2 equations together, the c2's cancel. -c1 equals 3, so c1 equals -3. So if c1 is -3, then 2 times -3 plus c2 is -8. C2 is -2, which agrees with Fenbox's answer. So the coordinate vector x sub b? What is the actual coordinate vector that they want here, though? Are we saying it's -3, -2? Okay. I get weirded out when there's an extra equation, I guess. But okay, Critical, I hope that's good with you for number 10. Let's take a look at syntax errors question, unless I see something from you. Do I have any tips on how to get a girlfriend? I literally do a math stream on the internet, and you're asking me for tips on how to get a girlfriend? My best advice to you is to ask someone else for advice. Fucking hell. Don't get your advice from a nerd who doesn't go outside. Ugh. Don't avoid the question. I think that's pretty good advice. It's not to take my advice. Bro, we know girls dig math students? I've been missing out then. So syntax's insights thus far. The cross product gives a vector that's perpendicular to both input vectors. I should read the original question first. Yeah, if my advice is to not take my advice, isn't that a paradox? Dumbbells like yeah. Given a line that goes through 1, 6, 4 and 3, 8, 1, using the cross product of the vectors A, B, and AC, compute the distance from the point. Oh. I feel like I've seen a problem like this before. I don't remember how we did it though. Your insights. The cross product gives the vectors perpendicular to both input vectors. The line connecting a point to its closest point on the line always lies perpendicular on the line. That's in 2D. Yeah. I want to look at this. I just want to draw the coordinates in Desmos. I feel like that's being a nice visual interpretation here. Hey, RumBJ. Yeah, I remember you. Is that more helpful here? Oh, shoot, you're right. I meant to click on 3D. They moved the button for 3D. Where is 3D? Why do they... I don't like change, Desmos. I thought you knew that. There we go. 1, 6, 4, 3, 8, 1, 8, 9, 5. Because magnitude of the cross product measured by magnitude of A, magnitude of B, sine theta. Yeah, sure. Will Desmos label these? A? Nope. So we're taking the vector from the red dot to the green dot, from the blue dot to the green dot. And crossing those, which... do you don't have a girlfriend, or do you have so many of them that you don't want to share? You know, let's just say that I have so many girlfriends that I don't want to share. Measures how orthogonal two vectors are. To find distance, you're looking to the orthogonal for the orthogonal distance. RumBJ, you gotta stop. Product measures. The number 0 is the undivided cardinality of the set of math nerds and girlfriends. God damn it. It's really funny sometimes. But yeah, so definitely at some point I'm gonna do, well, actually no, I wasn't gonna do that exactly. Do we want the vectors relative to C? Why don't we want C as the origin? Do I need to read the problem a second time? Oh wait, it's A should be the origin. I see. Okay, yeah, I agree with that then. The distance from the point C to the line AB. Huh. I don't know how the orthogonal distance. The set of Dom's girlfriend's S cardinality of left 0. Ugh. If only. The orthogonal distance from the point to the vector. Oh, syntax. In 8th grade, like what we, we were all like, it was at the end of the 8th grade year. Everyone was signing each other's yearbooks. It was the last year we were all going to the same school because in 9th grade, you switched to high school. This one girl in my yearbook wrote her phone number and called me with a winky face. And I was like, oh, that's nice. She wants to keep in contact. And I never thought about it again. Literally until one day I'm just sitting in the dorms in freshman year of college and it suddenly hit me, oh my God, she liked me. So I feel that. It's painful to like think about. I mean, it's funny now, but it's like, man, I need to actually like pick up on cues. That's why he doesn't start shooting until afternoon too, because he's chasing women out of the apartment. Yeah. Takes a while for them all to like clear out after breakfast. Yeah, that's like the calculus way to do it, Dr. Cook, I guess, but we do have to do it this cross product way, which I'm still kind of struggling to interpret. Google away. The few times I've used GeoGebra, I've raged at not knowing how to use it. How much percent I got in 10th and 12th? I don't know what that means. I feel like there should be some, like, pretty elegant answer with this, but I don't know. Oh. Okay, well that's the formula that we want. What is the sine law? Law of sines? Or I know that it's like the sine thing for the cross product. So we could just blindly apply this formula here. I don't know why it works. You want to actually show it? That's fair. Whoa, whoa. Calm down. Yeah, sure, critical. AB cross AC is the area of a parallelogram. Yes? I want to figure out why this thing is so... Like, this proof of it is so short. I want to see if I can figure out why that works. Put something in Discord. Oh, hey. Even if it's on a chalkboard. I guess I'll show it. Zach to the rescue. Oh. Wow, you only needed like 2 seconds to figure that out? Oh, really? It is that simple? Huh. Ugh. Okay, well, thank you, Zach. That's annoyingly simple. You just take sine theta equal to x over AC, just geometry, and then you do a sub on the sine theta for the cross product over the magnitudes. And the ACs cancel. Okay, yeah. Turns out Zach is good at math. I think we all knew that, though. I watch your stream. Okay, back to critical, I guess. Oh, geez, so we've got another 3 here. Do some stuff all day now. Yeah, it's one of those things where like it's so simple. Like I feel like I should have thought of it, but I sure didn't. A unique solution. Oh, sounds good, $10. Hope your grocery run goes well. Oh, mostly Maxi. Thank you so much for the raid. Welcome in, everyone. What were you doing? I gotta say, I'm not familiar with your stream. Max Wattage, Lunas Pain, welcome in. Oh, Brian was in there too. Thank you so much. Leak code and drinking soju. Oh, nice. Glad to hear it was a good time. Massive work. Okay. So yeah, welcome in everyone. My name is Don. I have a math themed stream where we, I guess, answer people's questions. I'm also not the only one who enjoys or who does like these math help streams. Here's a whole list of them. And yeah, I stream Tuesday through Saturday, but I only do math on Tuesday, Thursday, and Saturday. Haskell too? Oh, nice. Yeah, everyone, please go check out mostly Maxi as well. I already followed. I know I'm going to go say hi over there. So yeah, we're just working on this, some winning algebra questions from critical thinking in chat. People keep throwing 2 kilogram rocks on my head. Oh. I don't quite understand what that means, but fair enough. My brain's a little cooked from doing math for 4 hours. So I just assume that that my brain's going a little bit too slow to understand right now. Next has a math degree as well. Oh, cool. So I think for this one, Dr. Cook was saying to get the determinant of the coefficients here. Okay, yeah, I think I like that because I was worried about eliminating infinitely many solutions, but I think the determinant does take care of that. Um, uh, Oh yeah, Dr. Cook. That's fair. So critical, I replace the answer with the first column. I'm not sure I understand the math that you're setting up. Critical, let me say the way that Dr. Cook is suggesting. I think it's the best way that I can see. There's probably like a system of equations way of just kind of like doing some substitutions and stuff. But the determinant way is a little more direct to me. So let's translate this system into a matrix equation. 5s 4 5 5. Is that what we have? Minus 3 4. Hey, Kintsugi Studies. How's it going? Oh, and Muslim Maxi, thank you for the follow. I hope you've been well. I hope your studies have been good. Luna's Pink, thank you for the follow. Okay, so the idea with the determinant here is that whenever this system has a unique solution, you should be able to multiply each side on the left by the inverse of this and just get that unique solution. And a matrix is only invertible if the determinant isn't 0. So what we can do is we can give the determinant of this thing here. I'll do the absolute value bars. 5s 4 5 5, and we just care when it's not 0, because that means it's invertible and it'll have a unique solution. So let's give the determinant of that 2 by 2 matrix AD minus BC 25s minus 20. We want it to not be 0. I mean, you can make it just make it a little more familiar. We'll say it's equal to 0 and no to eliminate it. You can keep the not equal to, but it's all the same. Either way, you get s is equal to 4 over 5, and that's when it's this means when s equals 4 over 5, the determinant is 0. So there is no unique solution. That means there is a unique solution for all s not equal to that 4 over 5, which is the important part. Describe the solution. My s looks like my 5. It does. Studying master's program in a day, Kintsugi? Oh, that's awesome. Are you going for math, or it's been a little bit since I remember seeing you stream, but what are you going to be doing your master's in? You had math as a subsidiary subject to your degree, which is cybernetics. Oh, cool. Yeah, I have a bachelor's in applied math and then a minor in computer science. Been kind of trying to... The computer science especially I've forgotten so much of, but I'm trying to relearn a bit. Math, number theory, and adjacent stuff. Awesome. I'm trying to figure out the describe the solution part. We've gotten the unique, or we've done the first part of the question, which is determining the values for S. I don't know what they want for the description. Maybe the description they want is that given determinant won't be. Oh, it could be that, Cook, yeah. Gonna get breakfast? All right, Kintsugi, thanks so much for saying hi. And yeah, plan on streaming more. Check out Kintsugi if you want some studying streams. The term A will be, yeah, Critical, I'm not sure. You might be saying the same thing that Cook is saying, which I can't quite tell from what you're saying, Critical, but let me show you, I think, what they want based off what Dr. Cook is saying. We can find the inverse of this matrix. It'll have an S involved, but that's okay. And we could multiply it over on the left and get the actual, get an actual solution for x1 and x2 in terms of S. So I guess let's do that. We know the determinant of this thing is 25s minus 20. So we do 1 over the determinant, 25s minus 20, times the original matrix, 5s, 5, 4, 5. Oh, shoot, nope, no. We're doing we want to find the inverse. So those get negatives. There we go. So this will be the inverse of that matrix. Let's multiply in this though. That's 5 over that. The 5 will cancel. It's 4. The 4 doesn't cancel. We get a negative for that one. And that will be S over. So I say that's our inverse matrix. And we can take this inverse matrix and multiply it on both sides of the equation. That will cancel, and then we can know that x1, x2 is equal to this inverse matrix, 5s minus 4 over 25s minus 20, minus 1 over 5s minus 4, s, not 5, over 5s minus 4, times minus 3, 4. We can do that multiplication, and I guess that's as much as we can describe the solutions once we actually do that. Oh, the adjoint thing? Okay. And I think that's what the thing that I do is with switching the corners and negating things. My linear algebra is just too terrible to actually know that. Hard locked with the 69 bits. Thank you. Leave the determinant out front. What, you're not a fan of doing multiplication with this? Come on. It's so easy. I mean, it's not, there's not gonna be any cancellations anyway, so we may as well. I'm leaving it like this. Oh, well. Okay, maybe you have a point. I shouldn't have canceled these. It actually makes the problem a little harder. At least for that one, I shouldn't have canceled it. Too late. I made my bed. I'm sleeping in it. Minus 16 over 25s minus 20. 3 over 5s minus 4 plus 20 over 5s minus 4. That's just a 2x1 vector. You can simplify both of these fractions. That gets multiplied through by 5, so it's negative 15 minus 16 is negative 31. Yeah, I really should have left that out, but you know, I prefer doing things the complicated way. Evidently. So I guess that's as much as you can describe your solutions. You could have written a little bit simpler than I did. Even if it entails unnecessary algebra? Exactly. We need a bigger whiteboard. 31 over 5 times 5s minus 4. 4s minus 3. Oh, I forgot. I turned an s into a 5. Oh my god. Literally, I turned that s into a 5. Someone said that before, that my s's look like 5s, and I was like, yeah, you're right. And QED, that's the proof. So you could also have written this as 1 over 5s minus 4 minus 31 over 5 and 3 plus 4s, I guess. That's what you want to do. Oh yeah, it was you, Max. Thank you, Hardlocked. Hope you have a great day too. 4s minus 3. I got 4s plus 3. Well, I got 3 plus 4. Wait. So I agree with the minus 31 over 5 times 5s minus 4. Why is it 4s minus 3? Did I copy something down wrong? No? Okay, so critical, the only difference between our answers is that I have positive 3 there, you have negative 3. And I think positive is correct because you have negative 3 times negative 1 there. And I don't think I made a mistake earlier on. I'm right? Okay. Hey, Krish. I'm good. How about you? Oh, we have a Rubik's Cube solve. Corrupt, I'm saying 2. Let me go do that solve quick, just while it's on my mind. Okay. Inspection time. Oh, I mean, that might be like a 2-second penalty, but, you know, that's one of my better solves. 23 seconds. Yeah, I just solved it. What sports do you like? I'm not super sporty, but I like basketball the most, I guess. I play it sometimes with friends. Let lambda be an eigenvalue of an invertible matrix A. Show that. Really? 1 over the eigenvalue? Or wait. Picking up women is my sport of choice. Yeah, you notice that I have to be good at the sport that I like. So wait, is this saying that if you have an eigenvalue lambda of A, 1 over that eigenvalue is an eigenvalue for A inverse? I think that there's a little bit of typo in the sentence here, but that's how I'm reading it. Oh, okay. I think it's like a 2-step proof. Looking at the hint there. Oh, you gave it above? Oh yeah, I saw the symbols like well, those are symbols. You just left multiply by A, right? And divide by lambda. Okay, yeah. Okay, so let's take the hints as our first sentence. Suppose there is a non-zero x such that ax equals lambda x, just the definition of an eigenvalue. Oh, Brian, thank you for the 10 bits. And actually, this is maybe a 2-step proof here. What we want to do is say something about the eigenvalues of A inverse. So what I'm going to do here is left multiply each side by A inverse. These become the identity, and we don't care about writing the identity. And I believe that scalars can commute, so we can bring the lambda out front. I don't think it's really that important though, because now what we can do is divide each side by lambda. Say 1 over lambda times x is equal to A inverse times x. Can't you have 0 be an eigenvalue? Isn't that a problem? The point that we're supposed to make here is notice that this matches the definition of an eigenvalue for, or this implies that 1 over lambda is an eigenvalue of A inverse. And like that's the point there. Like we get to this form and then we have to notice that it matches the definition of an eigenvalue. I think it's a definition anyway, but it's a property if not a definition. Oh, really? Okay. So we might need some kind of caveat that A is invertible. What I wrote at the end is this implies that 1 over lambda is an eigenvalue of A inverse. Oh, so, okay, I guess we take care of that case when we say a non-zero x satisfies this equation, so we don't have to do anything extra. Oh, they do say invertible. Okay, that also takes care of it. Oh shoot, Scottish Daisy. I'm so sorry, I missed your message up there. Is this a Daisy wipe? Yeah, you know, they're just wiping all the servers like this week or next week, right? This is Daisy now. I really, if anyone did put a message in chat, I promise I didn't ignore you. I just, sometimes chat moves a bit quick and I'm doing the math when I wipe the board. Oh, shoot. All right, sorry. I ruined your joke. Okay, hey, and thanks for being here. Critical, are you still thinking about this one, or does that make sense? It's good? Okay. Given matrix A, find the basis for the corresponding eigenspace for the given eigenvalue. Oh god. For the corresponding eigenspace. Oh, does this mean there might be multiple vectors? Would an eigenspace, I guess, maybe be more interesting if there's like repeated eigenvalues? Is that what's happening here? We definitely, with lambda equals 4, we definitely get 2 rows that are the exact same. Okay, I don't know exactly what to do with this problem, but I'm fairly confident that we gotta let lambda equal -4. One of the exact same. Now look at it. And get the determinant. Maybe I should Google it first. Okay, good. That is what I thought it would be. The eigenspace in question is a null space of A plus 4i. So we do A plus 4i instead of equal to 0. The determinant of that. No? Not the determinant, just the system of equations. I think I think the question is basically asking find the eigen vector or vectors associated with lambda equals -4. So let's just write down the original matrix. 1 minus 5 minus 5. And so when we find the eigenvector, we're going to do this diagonal minus lambda, but lambda is -4, so we're minus -4 is the same as adding 4, so we're going to do 1 plus 4, 1 plus 4, and minus 9 plus 4. We get -5s everywhere else. Look at that. What a matrix. And it's equal to zeros. They all have slightly different signs, though, funny enough. I guess let's just start adding rows then, because it's not immediately obvious to me what's happening. Let's add row 1 to each of the rows below it. Five plus -5 is 0. -5 plus -5 is -10. -5 plus -5 is -10. -5 plus -5 is -10. Okay. What's up? Bottom left 5. Oh, I flipped a negative. Thank you. Yep. And thanks, Zone, for redeeming that. I just put a negative sign there for fun. I just really wanted everything here to be -5s. I don't know why I erased these other two. Wait, well, I shouldn't have... That makes that last step not helpful. Wanted to subtraction there, I guess. And I saw you said that you can get an eigenvector by inspection, but I don't see it with inspection, so I'm going to actually go through and solve this. -5 minus -5 is 0. -5 minus -5 is 0. And I guess we're nearly done. -1. Well, not done, but done with the first part. Why did I say 2? Little 1. Okay, so this implies that x1 minus x2 minus x3 is 0, and that x3 is 0. Oh god, did I mess up another 5? I keep making mistakes, Fembox. Second row, third column. Dude, I'm not paying attention. Okay, thank you. That one I copied down wrong. I didn't just make that one. Well, this is wrong now, isn't it? That becomes a 0. Okay. One -5 -5, -5 1 5, 5 -5 -9. That matrix I copied down right. We added 4 to that diagonal. 5 5 -5. Okay. And then now these two rows do clearly become 0 after doing these operations. Okay. So that means all we have to go off is that x1 minus x2 minus x3 is 0. So that means our x vector, we have two free parameters. x1, this implies that x1 is equal to x2 plus x3. So we have x2 plus x3, x2, and x3. I don't know if this will, there's probably a bit more we have to do after this, but if we split it up based on the x2s, we have 1, 1, 0 times x2 plus 1, 0, 1 times x3. Oop, not x cubed. Is this actually a basis? I thought we had to do something more. Pay attention, 007. Yeah. Same basis vectors you had? Okay. I thought we were gonna have to do something when you have like a repeated eigenvalue, you have to do a second system. But maybe not. Actually, I mean, oh, I misinterpreted where they're going with the question, I think. This is probably it. Let me plug the matrix into Wolfram and click at all the eigenvalues. I mean, if it was a repeated eigenvalue, I would hope that they say that. That'd be really mean if it didn't. It is repeated. Well, wait. But we do get two vectors out of this. I thought you had to do something different. Huh. Yeah, okay. I think it's the right answer. Because this third vector definitely goes with lambda 3 equals 1, so. There's nothing else like to put in there, even if I wanted. Let's see, put in two more. God, this... It's a lot of linear algebra. You're just putting everything? Super dark closet side map. Ooh, I love a good storm. Oh, it's one of these questions. The determinant is the product of the eigenvalues? Really? That's kind of crazy. Yeah. So I think we're gonna take row 3 and send it to row 3 minus row 1 and then expand along this column. It's the easiest way that I see. And if you do a row operation like that, you don't even change the determinant. You don't have to worry about signs or anything like that. Goodbye, eraser. One, 5, 4, 1. Wait, is that -5? No, 1, 5, 4, 1. 0, -3, -6, 0. Three, 5, 4, 1. -6, -6, 5, 5, 0. Double check it. 3, 5, 4, 1. 0 minus. Okay. Okay. So before we go about getting the determinant, let's take row 3 and set it to row 3 minus row 1. And that doesn't change the value of the determinant, as it turns out. And it makes the determinant much easier to compute. So we're doing 3 minus 1 is 2. 5 minus 5 is 0. 4 minus 4 is 0. Wow, they're really making it nice for us. 1 minus 1 is 0. -6, 5, 5, 0. So now either that column or that row look appealing to expand on. I'm going to choose just the right column for fun. We do have to worry about the whole plus minus thing. So that does mean we have a negative sign if we expand along that one, but that's fine. So we're going to put a negative, and it's invisible, a -1 times the determinant of the 3 over 3 matrix from down here. 0, -3, -6, 2, 0, 0, -6, 5, 5. And now we have a simpler problem, and we actually have a pretty good row to expand on right there. So it's plus minus plus. So if I expand along this row, we do have another minus sign, which actually works out nicely because there's a minus sign out front. So we're going to have 2 times, I'm going to read the minus sign entirely because of the plus minus plus. So expand around 2, -3, -6, 5, 5. That's just a 2 by 2, which is pretty quick. -15 plus 30, we get 30. That one is, it seems like it's engineered to be nice, thankfully. So there's like a not nice version of this question that could have easily been asked there. Are you good with that answer, critical? Okay. A is row equivalent to B? Oh god. Is there an easy way to do this? I don't want to do row operations. I think I mean, okay, they make the row operations maybe not so bad. I think that if you do row operations to A, you can end up with B. Which I think it's a equivalent way of saying that. The span of the rows are the same. But I assume they just want you to do row operations to A until you get B. Or the other way around if you feel like a masochist. The basis for the column space of A. Oh, I mean, I guess you just, well, oh, the pivot, that's why you said pivot columns, fembox, that's going to be the answer for the second part. I guess it makes sense, yeah. my linear algebra class only had computations, and I've had students when I was a tutor ask me if I can teach them linear algebra, and I say, yeah, sure. And then they show me their homework, and it's like, what the hell is this crap? So let's write down A. -1, 3, 7. Dude, this is typo heaven right now. -1, -2, -7. -1, 3. 2, -4, -9. -5, 1. 3, -6, -11. -9, -1. Okay. So let's get all zeros in these three spots first. So row 2 will be row 2 plus row 1. Row 3 will be row 3 plus 2 row 1. Row 4 will be row 4 plus 3 row 1. Now we have a lot of arithmetic. 1 plus 1 is 0. -2 plus 3 is 1. 0, 1, 3. That seems reasonable. Now 2 minus 2 is 0. -4 plus 6 is 2. -9 plus 14 is 5. -5 plus 4 is -1. 1 plus 0 is 1. Okay, 3 minus 3 is 0. -6 plus 9 is 3. -11 plus 21 is 10. -9 plus 6 is -3. -1 plus 0 is -1. Okay, let's multiply that one by -1. Let's get rid of the 2 and the 3. Row 4 minus 4. That's not right. Helps if you scream when you make a typo, I found. I'll catch up on that chat in a minute. Hello to Swanit over on YouTube. Oh, I multiplied you 3 by -1, didn't I? Okay. 0, 0, 5. -1 minus 2 is -3. 1 minus 6 is -5. 3 minus 3 is 0. 10 minus 0 is 10. -3 minus 3 is -6. -1 minus 9 is -10. I think we're nearly done. We just get rid of the bottom row. Yep. So we're going to take row 4, send it to row 4 minus 2 row 3. 0, 0, 0. Okay, so that we've shown that it's row equivalent, I think, with those row operations. Ugh. Now what's with the column space? Do not have the same column space. The last column of A. It's obviously the column space of A. What information of B can give the last column. Oh, that's interesting, Bluebird. Didn't realize that. Oh, so Fembox. So the procedure that Fembox is saying might answer the concern from Bluebird, which is if we notice in column B, or we can take whatever columns in B have a pivot and see it's the first 3 columns. And then if we want the column space for A, we take those corresponding 3 rows from A, is what the answer would be. I would just be, I don't know that for myself, but I can go with that. Well, that's what I'm trying to figure out, critical. I don't know for myself, so. You probably could, Dr. Cook. I assume there's a point to asking the question in this way. Critical, if Fembox is right, then yeah, those are the columns that you want. don't know what to Google to find the thing that I want. Hey, Saptam. If you have a question, feel free to let me know, but if it's something too involved, I might just say no for the day. I'm going to call it quits soon. So critical, I can't confirm it, but I think you're supposed to use the row reduction as a key to know which columns from A you want. Any column as a pivot in B, you want to take as one of the bases for your A. So the first 3 columns in B have pivots, so the first 3 columns in A, I think, are probably the answer, which is what you put in chat before. I don't know that for myself, but that's the most reasonable thing that I've seen. Dr. Drunkenstein. Oh, chess fan. If a plus ib is equal to x plus I squared or 2x squared plus 1, prove that a squared plus b squared maybe I can solve that. Let's write it out. No worries, critical. Yeah, I hope your final goes well. And thanks to the people in chat who've been helping. Cook, Bluebird, Fembox. People I'm forgetting, I'm sure. X squared plus 1 squared. Two x squared. What? Oh, really? I feel like there's an easy complex variables way to do this, or easier at least. Yeah, this is from YouTube, Cook. My instinct here is to figure out A and B explicitly from the formula here, and then just manually calculate a squared plus b squared. So let's multiply out the top. X squared plus ix plus ix plus I squared, which is minus 1. So for the real part, we get x squared minus 1 over 2x squared plus 1. For the imaginary part, get x over 2x squared plus 1. No? 2x. Just oh! Wait. how do you conjugate the right side? Oh wait, well, just multiply. How do you calculate the conjugate of the right side? It is fourth? There might be a typo in the way that it's written because there's only squares in the original thing. Just replace I by minus I? Oh, it's that easy? Okay. Oh, okay, you're saying there's an implied fourth. Never mind. Timberland Alpha, where can I get legal free textbooks? I think OpenStax, is that what you're asking? I think this website has free legal textbooks. Get rid of that, get rid of that. Okay, so there's an easier way than what I'm... So yeah, like I said, there's an easier way to do it if you're better with complex variables than I am. Well, okay, let's just if these two things are equal, then their conjugates are also equal. So on the left, I'm going to multiply by a plus ib conjugate, and on the right, I'm going to multiply by the conjugate of this thing because those two things are also equal. So a plus ib times a minus ib. And the point of this is that this multiplication gives you a squared plus b squared. Times, and the conjugate of this thing is apparently just x minus I squared. So on the left, we get a squared plus b squared as desired. On the right, so the top multiplies across the top, and we can save ourselves a lot of algebra and heartache here if we rewrite the numerator like this. So we have something squared times something squared, and when you have that, you can put parentheses in the squared on the outside, and this math inside here is much easier to do. And then on the bottom we have 2x plus 1 squared times 2x plus 1 squared, so 2x squared plus 1 squared. Let's do the multiplication on the inside here. X times x is x squared. We get negative ix plus ix, which is 0. And then I times minus I is positive 1. Squared still on the outside comes down. That and that match, so we're good. Thank you, Cook, for the call on that. Oh yeah, sure. Trunkenstein. So basically the idea is that these two things are equal. If a plus ib is equal to x plus I squared over 2x squared plus 1, then the conjugate of a plus ib is equal to the conjugate of x plus I squared over 2x squared plus 1. And because these two things are equal, I can multiply both sides. I can... There's almost like a few things happening in here that I glazed over and I probably shouldn't have. So you're allowed to multiply both sides of the equation by the same thing. So let's say I multiplied each side through by a plus ib conjugate. But a plus ib conjugate is also this, and I'd rather have this form on the right side. So just on this one, I'll substitute out x plus I squared over 2x squared plus 1 conjugate. So there's a couple of like steps involved here that I glazed over and I probably shouldn't have, but that's the logic behind how I got to this step here. Dr. Cook, I wish I could, but Twitch specifically has a policy against that. It's the type of thing where if you just did it, you'd probably get away with it, but I haven't been wanting to really test that yet. Twitch only recently, like last year, allowed you to dual stream at all. Your tuition teacher made you write an entire one-page solution for it? Jeez. Yes, I'm just reading your problem now. Base BC of an equilateral triangle lies on the y-axis. Coordinates of C is 0, -3. Jeez. So wait, if you won't be able to hold this down for much longer, we'll rise up. I've been half tempted to just start showing the YouTube chat on screen and seeing if I get caught, but I haven't worked up the nerve yet, I guess. So it's really annoying. It makes no sense to me because they say it's because if someone in YouTube types something that's against Twitch's terms of service, they would have to ban the streamer. But when a streamer plays a multiplayer game, people put some heinous stuff in the multiplayer text chats or say it verbally, and I don't get what the difference is. Anyway, what are you trying to solve for here, Saptum? I don't understand the question. Don't dare punish a big-time streamer like me. We have the setup for a question. I don't see what they want us to get. Oh, I'm sorry, I missed it. That's my bad, Saptum. Yeah. No worries, Timberland. Okay. Putting all these chats together. There. Wait, let's draw this out. So wait, we have equilateral triangle. Zero minus 3. Okay. Oh, C. Dude, I can't. B. And A can be left or right. I don't think we have a specific indication of it, but it doesn't actually matter. Oh, actually, it kind of does matter. So what I'm seeing is that A could be over here or over here, and I don't really know how to tell which one. I think right off the bat, we know the origin is the midpoint, so that's why I put B3 above the origin. So we definitely know that the coordinates for B, at least, are 0, 3. I don't know if A should be on the right or the left, though. I'll just take A on the right, I guess. We do? Oh, okay, this is, okay, never mind, okay. So now we need to think about the distance from, I'm just gonna assume A is on the right side, but this is, you could do everything I'm doing on the left side here, and we just don't know from the information that we're given. But what I'm thinking about here is that the distance from B to C is 6. Because we're going from 0 to 0, 3 to 0, minus 3, that's 6. So it's an equilateral triangle, which means that somewhere over here, we need to find a point A that makes a distance of 6 with C and a distance of 6 with B. It won't be all the way here out at 6 because we're coming in at an angle. You know, we're losing a little bit of that 6 distance. So I'm just gonna, this red dotted line is not going to be exact, but I'm just gonna arbitrarily put A somewhere around here for the sake of having something to calculate with. A could slide along like left to right though. I'm just naming something here. So we know that this is length 6. We know that just this is length 3. And well, I see a right triangle inside of here. We have hypotenuse, we have 3. Let's just use Pythagorean theorem to figure out the top side, and that'll be where A is. So we know that 6 squared is equal to 3 squared plus A squared. Maybe A is a poor choice here, but the x-coordinate of the point A. So that means 36 is equal to 9 plus A squared. 27 is equal to A squared. I want it to be 25, so it'll be a perfect square, but unfortunately not. It shouldn't be a perfect square, probably. So we take the square root of each side. We only take the positive square root. You should be careful when you take the square root of each side of an equation like that. You technically need a plus or minus, but this is a geometry problem, so we only care about the plus. But a little tip, if you're doing like an algebra problem in the future, you should do a plus or minus there. The square root of 27 simplifies because 27 is 9 times 3, and 9 is a perfect square, and the square root of 9 is 3. So, and this might be something you just plug into a calculator too. If you don't know how to do this, just don't worry about it. Root 27 is something you can plug into a calculator and get a perfectly fine answer for. But what this means, either form you use, whether you get a decimal or the exact 3 root 3 form, is that the coordinates of A, like this distance here is 3 root 3. So that means the coordinates of A are 3 root 3, comma 0. I hope that makes sense, Saptem. Let me know. No worries. Oh shoot, and like I said, it's correct. Awesome. One thing I forgot, but like I said before, you technically have another possible solution over here at -3√3. But I just kind of arbitrarily said that it's the one on the right. It could be the other one too. My record for the longest math stream. Oh, well, thank you so much, Septum. Appreciate it. That's a good question. I wonder, I mean, it wouldn't be for all my videos, but like I could see my longest YouTube stream and I only ever streamed actually, can I see the record for my longest YouTube stream? Let's see, can I sort it? No, I can't sort it by length. I think I've got longer. 24-hour stream incoming. You did 6.5 hours last week. Yeah. You do a 24-hour stream, I guarantee I'll sleep through most of it. My longest math stream, I'm gonna put it around. I would bet I've done a 6.5 hour stream as well. I can't think of the specific instance when it happened, but if the questions are flowing, then oh really? Does that filter for category? Because like, if you're talking about game streams, then gone way longer. But math streams are pretty mentally taxing. Oh, dang it. Okay, I mean, can I? Yeah, I definitely, for games, I definitely have streamed for at least 9 hours before. I don't know where to see it. I don't know. Who cares? You know, I meant to look at this thing that Milk was talking about before. I'm too tired now, though. Well. Oh, the Pi Day Marathon, of course. There's a wiki picnic? Huh. Okay, we got a call, though. The math is pretty freaking mentally taxing, and it's a lot harder to do a long math stream than it is to do a game stream, I can tell you. Joseph 3 hours ago redeemed a drawing. Should I do that quickly? Yeah, you know, actually, let's do Joseph's drawing. It's a quick one. 13 hours? When was that? Oh, you're oh duh. It was just a few weeks ago. Your week marathon. Or over a week. Joseph redeemed me to draw a smiling coffee bean who is a shining beacon of happiness. I did the Rubik's Cube. I'll do that one also though. I don't care about breaking my math record though. Let me do Joseph's drawing. It's been, I doubt Joseph is even here still, but I feel bad because I don't think I did his last drawing either. A happy coffee bean that is a shining beacon of happiness. Orange is the closest thing I have to coffee bean color, so should be a little more oval. A lot more oval. How do you draw happiness? Okay, we can, I'm not an artist. Let's see. Like, actually, those are like worried eyebrows. I want to like, this coffee bean is really unsure of itself. There we go. And I feel like it needs to do the little like finger guns, you know? Oh, dude, I shouldn't make this harder on myself. How do I draw like finger guns? There we go. Yeah. The shortest little arms. Oh, we got 2 Rubik's Cube solved. Well, you guys should. If you try, you know, my best time for Rubik's Cube is like 17 seconds, so you have to redeem a lot of them. How many various math chads been streaming on here? Have Don and Zach been streaming for over a year? Yeah, I started streaming January of last year. Zach started streaming a few months after me, I think. Tencent and Obi are the OGs. Gold, I have no how long. I have no idea how long he's been streaming. Actually, I checked out called Boring Math Professor. Oh, dang. Stream that never ends. Yes, it goes on and on, my friends. Yeah. Oh god, we gotta Zach. Quick math. The number of items in half a gross. Oh crap. A gross is 144? So half a gross is 72? 6 choose 2 is something annoying. 6 factorial over 2 factorial, 4 factorial, which is 3 times 5, which is 15. 72 divided by 15? Oh, no, times. 72 times 15. Oh god, that's annoying too. 720 plus 72 times 5. 72 times 5 is 360? There's no way it's 360. No. Yes? It's 360. 720 plus 360. 1080? I'm all wrong? Okay, fine. I felt pretty proud of that mental math. Wait, right? Hey, Mary Bosk, do you teach math for babies? What is Guru plus Gaga? Yes, I do. Only babies are allowed here. It keeps the math much easier for me. No, if you ask about the drawing that's above me there, I have a channel point redeemed for people to make me draw things. And so that was one of them. It's a smiling coffee bean who is a shining beacon of happiness. Okay, so we did Zach's quick math. Surprised I could do that one. And then we have 2 Rubik's Cube solves. Where's my Rubik's Cube timer? You know what? Sure, you can have persistent data storage website. I always imagine that, like, anytime a website pops anything up on me, if I hit yes to whatever the website is asking, I just assume that some kind of clone of me is going to show up at my door, like, and kill me and, like, assume my life. You know, it's a very rational fear. All right, it's scrambled. Let's inspect. I'm not doing a good job of inspecting here. Bam, bam. Thank you, ma'am. Oh God, I'm choking. I'm choking. We're good? No, oh my God, I can't. Oh my God. Terrible. I can't find the pieces that, or the pieces that I need. This stupid perm. That could have been so much better. All right, that's one solved down. Let's do another. Okay. ABC, always be Cuban. Only marginally better. Oh God, and Zach did one, okay. Wait. Okay. Okay. This counts as abstract algebra studying, right? Oh, I'm gonna mess this perm up, dude. No, I didn't. I got it right. I got my favorite perm to do for the end case here. Oh God, Cook did another one. It's oops, not that. I'm a little bit out of practice with it, so I thought I was gonna. Oh, that time I did mess it up. Oh crap. Well, I got myself in a predicament now. Okay, fine. I'm not going to show the perm that I wanted. Yeah, I used to be right around 25 seconds. I'm washed up now. Where's it? Oh, there it is. I fucked that up. Make my own cover for a book I would write? Oh my god. Yeah, I always start by solving the whiteface. And I end with, I mean, you orient the yellow and the, there's like 4 stages. One is you get the cross, then you get, at the same time I do a more advanced method where you get both the corners and the sides, and then you only have to deal with like the top part there, and that's two phases on its own. But Joel Letsep over on YouTube, I have questions like, how do you go about plotting a graph with an ideal scale, such as 1, 2, 5, 10? I'm not sure I understand what you mean with that question, Joel. Like, how do you choose how to scale your graph? My strategy for women, cubing. Oh god, it's not a very good strategy. Got me nowhere in high school. Because like the reason I got good at solving cubes, I mean I'm not even all that good, but like decent, is I was just super bored in high school. My friends were into solving Rubik's cubes, and I'm like, oh, you know, I'll learn that too, because my teachers would think that I'm cool and texting my friends, and they'd tell me to put my phone away, and then I just hold up my cube, and they'd be like, oh, and then they wouldn't care. Jokes on them for thinking that I have friends. I do have friends, but the book cover for a book I'd write. I guess we have to answer the question of what book would I write before I can make a cover for it. Yeah, I grew up in the Bay Area. I went out of state for college to Hawaii, and then I came back here after. Okay. I think I have my idea for the book. Okay. So, I picture, actually, this is annoying me. There we go. For whatever reason, what's coming to mind for me right now is writing some type of motivational book. So the title of it is How to Slay at Life. And on the and like for the picture, I don't really have to have a good color for it, but I picture me like very heroically on like some kind of like point of a rock with an ocean below me. And because it's, you know, how to slay at life, It's gonna be, I shouldn't have drawn this point so pointy. I don't have room for me. It's a little better. It's gonna be me. Okay, I wish there was some more like detail here to show all my like muscles, but holding a sword is the idea. And just to make it clear that it's me, you know, get the glorious beard in there. Don does math and Carl Sagan. I'm just gonna throw his name on there, even though he's dead and can even consent to that. You know, who's gonna sue me? Probably could absolutely get sued for actually trying to do that. Rock and Stone. College and Wyatt, yeah. Colton Brennan Land? I don't know. Brennan. I don't know who that is. Colt Brennan. Oh, a football player. Cuban the other hand? You know, we can do that. Oh god, a disaster is about to happen on my desk. Okay. My headphone cord is about to like drag my my wireless mouse off the desk. I'm probably gonna get the orientation of the sides wrong, but who cares? Like I'm gonna have it mirrored. There we go. This QB the state of Hawaii has ever produced. That's probably the list of QBs Hawaii has produced is probably pretty short, but yeah, what Funbox said. Oh my god, what did you say that the record was? Did you guys actually get me to break it? What did Zach say earlier that the record was? I'm scrolling up. I think it was just under 6 hours. So if I hit 6 hours, I should be good. 5 hours, 58 minutes. Okay. Carl Sagan. Oh yeah, Joseph, I did eventually get to do your coffee bean. All right, well, I guess you guys did actually get me to make it worth breaking my record since it's literally only 2 more minutes now. We're gonna pass the time though, you know, we got 2 minutes here. Do I have anything like fun? I can do show and tell. How about this? Do show and tell. This, actually, let me go to the big camera. This, it's an art book inspired by Dark Souls. A YouTuber that I really like who does Dark Souls lore videos contributed like the content. It's called Soul Arts. It's very nice. Let me, I had some of my favorites like bookmarked. It's a really nice book. I'm a sucker for fancy books. And this is a fancy book. And I think my favorite one out of the entire thing, oh, it's gonna look terrible in this lighting. But this is a picture of Katerina, which is a place that the game talks about and you meet people from, but you never actually visit. And it's just a cool place. I hope it's showing up okay. It's probably not. This is a terrible idea to do considering my camera and lighting, but you know, I'm here. Let me see. One last math problem? No. I've done so many math problems. My favorite Carl Sagan quotes? I'm gonna be honest, I can't actually think of one right now. I need to watch and read more Carl Sagan stuff. I started to read one of his books, I think. Oh, you know, he has a really... I haven't read the actual book, but he has a really nice passage that I've read in like the foreword to one of his books, I think, or something like that. But it talks about how he foresees a future where people become less trusting of science and like anti-intellectualism is on the rise. And it's a little too true today now that the future has come. If it's an old final exam you gave in multivariable calculus, you can work on it next stream. Ooh, or on stream, you said. And that could actually... Oh, then you can be done? Oh, God. I still need to do Penn Center's test. I want to do it. Yeah, you said this stream. That's true. That actually might be kind of a fun filler thing. Yeah, I did watch the Neil deGrasse Tyson remake. I thought it was good. Coffee's making people's lives less shitty since 1889. Yeah. I mean, people have been drinking coffee for a long time. It's pretty traditional in Ethiopia. Yeah, I mean, I should see your favorite problem in multivariable calculus. Let me put my book away. Yeah, this is a really cool book, though. I'm a little bit annoyed because there's a typo on one page. And it's an expensive book. Like, I don't want there to be a typo in an expensive book. There was. And I emailed the people who did it, like, just to ask to make sure it was a typo and I'm not being stupid. And they did offer me a new one, but, like, I kind of felt bad asking for a new one, so... Cosmo taught me how Eratosthenes first calculated. Oh yeah, I learned that. Where did I learn that? I learned that somewhere. But yeah, he made his assistant walk like he made his assistant count the number of steps it took to walk from like Alexandria to a pretty far away city directly south. Show and tell is a channel point redeem. Make it pricey though. Wonder how much stuff do I have to show and tell about? I got a couple things that I could do. Okay. Yeah. Wouldn't be hard to just make the basic redeem now. Especially because we're going to see if Zach can find his favorite multivariable calculus class. Posted? Okay. I'll do the redeem later then. What is this figure? See the vector field f equals 2xy squared minus 1 comma 2x squared y. Evaluate. Oh, it's a conservative field, isn't it? I hope. That would make it a lot easier. So the path shouldn't matter. Is that Math 10? Is that the name of the class? Or any orientation that's convenient? Actually, okay, I might be getting my terminology wrong. I haven't showed for Paul once this stream either. I assume it's one of those ones where the path doesn't matter. The partial with respect to y equals the first one with respect to y is 4xy, and that's 4xy. Okay, yeah, so it is conservative. How do you actually use the Math 2210? Oh. Good luck in the curve. How do you actually take advantage? I mean, I'm not seeing the actual theorem said that. Oh wait, I think Paul, like, for Calc 3 and differential equations, I don't like it as much, but I think the conservative, or like the path independent part is, like, they talk about conservative fields before they actually define it, I think is the issue. As much as I do love me some Paul, the later you go in the content, the less I like it. It's still good. Should I just assume that it's path independent and do the line integral from 4 to -4? There we go. Continuous vector field, conservative. Oh wait, really? Am I misremembering? No, you're gonna LaTeX that curve? There we go, independent of path. Okay. Mary Bosk, do you think one of these days can you teach contemporary math? What is contemporary math? That little description seems like I might like it. I can't say that I've like taken any class called contemporary math before, but I bet I could learn this without too much trouble. So if you have a specific question, feel free to let me know. And actually, in case you're interested in math streamers in general, let me give you a list of people who I can recommend who all do math help. And Dr. Cook's also been streaming. Give him a shout out too. Yeah, one thing that I really wish my multivariable calculus class connected these terms to the physics, because I had no idea that conservative vector field in this context meant the same thing as a conservative force or whatever it's called. I am losing my words now. Hey, Neon. And remember what a line integral means, but how do you actually evaluate a line integral again? We have a vector field. Beard has grown? Yeah, I trim it on Sundays, so this is the longest that... I mean, I probably don't do a very good job, a very consistent job of trimming it, but... Like Wolverine? I'll take it. Yeah, Purcell already has a lot. I'm just too tired to remember the actual connections. There's another one where like there's a word that we use all the time. It might have been differential equations though. F, okay, we parameterize it like that. I think that's the key. And we can parameterize the path. That's it, right? No, I mean, not from scratch milk. I keep it around this length and I like trim it down a little bit once a week. So what's the parameterization of our path here? Oh yes, Heptam, I'll take a look at that after. So if we make our parameterization, we can just keep our life simple and say t 0, 0 for minus 4 less than t less than 4. Okay, yeah, looks like I got to the same thing as Cook. So we do f of r of t. So, well, that's actually, okay. X is t, y is 0. I don't know why did I put the third dimension on that? So that becomes -1, that becomes 0. Wow. Dot it with r prime. That's our integral? Oh, wait. There's 3 negative signs. -8? Is that right? Oh, best viewers. I am the best viewer. There's only one. Hell yeah. Do it on the OG path to verified. Plus 8 is also accessible. Oh, okay. Okay, so Septum, you put a question in, and then I do have to end with your question, Septum. The center of the circle. Ooh. Okay. My favorite project problem. So you said to elaborate because you're weak in math? And that's completely fine. I'll try and feel a little more. I'll try to explain it more than I normally would. Find x of circle passes field points 2 minus 2 and 8 minus 2. Well, wouldn't that mean that it's 0 though, Cook, if it is a loop? Well, I don't know. I don't know. I shouldn't. So what points does the circle pass through? 2 minus 2, 8 minus 2. So we're given 2 points, which are 2, negative 2, and 8, negative 2. Find x if the circle passes through x plus 2, comma, x minus 5. This is like a puzzle. I think we get a system of equations out of this. Oh, wait. Oh, Neon, did you already help out Septum? If it was solved for me, I'm not above that. Septum, are you good with what Neon said, or do you need any more help, or did you get everything that you need? Oh, that's a fair point, Cook, yeah. Yeah, it would be weird to specify 2 points if it is a closed loop. Except yeah, I know I was padding your record. I know. On Tuesday, you guys are going to make me go for even longer, so I should, like... You got it, Septum? All right, perfect. That's the most important part. So I'm saying it's 5, negative 2. So you're saying that x equals 3? I didn't think that would make the solution that simple, but that does seem right, yeah. I was gonna do it like more generally and get like a system of equations or something. I don't really know what I had in mind. I was gonna do something, I'm sure. Okay, let's call the stream here. Is there anyone around who's rateable? Looks like Mary's going. Oh wait, oh, there's also astronomy show. I have rated Mary pretty recently, I think. I don't, oh shoot, I need to cut the YouTube stream off. Neon and Septum, thank you so much for being here. Anyone else who's on YouTube? I appreciate you all, but I do gotta call it quits for the day, so. I'm sorry that you two are like having a conversation. I think the chat is still active after the stream is over, but I do gotta cut it off, so I'll see you around Septum and Neon.